Thank you and welcome everyone. So today we are going to talk about two things. One is on the product side, so that we can give some overview on one of the products and our vision there. And then my colleague Harit, who is also here, he'll talk about AI and ML best practices and operations that we have. So we'll start. All right, so the product that I'm going to talk about is called Falcon Exposure Management. It is under the realm of proactive security, and we'll talk about the really high level. I understand that the interest here is more getting into the depth, so we can certainly answer any questions or even talk about further details at the booth if you can visit. Here we'll keep the focus at very high level and bear with us for that. And then Harit will talk about other things on the AIML. Okay, so what is the objective of Falcon Exposure Management? Is to slow down on the adversary activities by proactively looking at what are the risks involved. So at CrowdStrike, our motto is we stop breaches. So if you see in the industry, breaches are everywhere, whether it is a small size company or a government organization or a nation state, it's everywhere. And as per the IDC survey that is recently published, as many as 1/3 of all the organization, they had some kind of ransomware attack or a breach in last 12 months. So you can understand the extent of the impact that adversaries are creating in the overall ecosystem. So why we are here? We are a security partner. We can help you stop breaches. We can help you defend against the bad guys. And ultimately, we can help you to reduce of getting your brand into limelight in that sense. So we live the mission. We don't have a mission statement. We just say that we stop breaches because that's our objective, to stop breaches and to help our customer to do that. No, back. Moving forward. Okay. So what is the problem that we are solving? So if you see traditionally how security operations are run as far as the proactively looking at the security posture is they look at various aspects of security, what are the different assets there, what risks are associated with it, what vulnerabilities are there, what exposures are there. And typically the tools, pause there or they give a perspective only to that extent. But is it the real problem? Is it that you have a vulnerability related issue? If you look at it, it's not really a vulnerability problem. It is an adversary problem. Ultimately, what you are protecting your organization against the adversaries, right? So that's where we need to focus on. That's what CrowdStrike helps you to do, is to identify the risk and look at the risk from the adversary perspective, operate on that risk in terms of mitigation plan, as if understanding what the adversary would do and build your defense against those adversaries. Now, what is the current challenge? So if you see in any organization, typically the security teams, they have multiple products and they operate within various alerts, reports, false positives, true positives that or false negatives for that matter that these products generate. Okay, and most of their times goes into correlating this data and then identifying the meaning out of it and then acting on it. Right? And this is what the adversaries know, that these are the challenges, and they hide in the gaps which are generated by these tools. And then they make entry into the enterprise. They laterally move, they do their job, steal the information, create the impact, and the security teams just struggles to defend their organization against these attacks. Right? So what you need is actually not just look at what is the risk involved and get yourself into these aspects of reports and alerts, but you need possibly some way by which, it's imagine that if a security analyst visually understand what matters the most in terms of something that they need to protect, and what matters the most in terms of something that they need to fix, so that they can keep their posture correct and their posture defendable, then that is the way modern enterprises would look at protecting themselves. Right? If you want to operate that, either the cost is more, complexity is more, or the deployment operations are pretty lengthy. Right? So what if we look at this problem as a cycle, which is a combination of proactive security, which is looking at which vulnerabilities matter the most, okay, and helping the team to reduce adversary opportunity. First is to minimize the opportunities that adversaries have to enter into your organization. But whatever we do, the truth is the adversaries are smart, nimble, they are going to enter your organization, come what may. There is no 100% guarantee from anywhere that adversaries won't enter. But if you have, coupled with proactive security, if you have active protection, which can help you to reduce the activity once the activity of the adversaries once they enter your organization, that will be the key. So the combination of proactive security and active protection can help you, maneuver through this security posture better. Now, how do we do that? So we launched a product called Falcon Exposure Management. As I said, going through these point products, it's very difficult for a security team to defend their organization. But what if you have a complete solution which is cohesive enough to look at all of the aspects? First is you need to know what you have. First is you need to know what you have in your organization, which is what assets you have, which of those assets are critical that you want to protect, okay? What is their posture? And then how do you prioritize any security problems that you may have on those assets, okay? Which ones you need to fix, which ones you can't fix but you can mitigate, okay? So ultimately it's a cycle. It starts from discovering the assets, assessing their posture, prioritizing and remediating. And it's a continuous process. But do remember that this doesn't happen only with technology. Proactive security happens with technology, people and processes together. So the exposure management is a way by which we can help in that journey. So we discover assets from inside out, which many tools do, but we also do outside in. So we map the internet, we map the whole internet. Okay, and then we tell you for your organization, what are the assets which are exposed to internet? Those are the assets through which the adversaries are going to enter. So you need to know first what are those assets. Then you organize the assets. You identify which are the critical of those assets. So you have established what is there in your organization. Then you assess them in a real-time manner for vulnerabilities, misconfigurations, assets which are out of supports, applications which are not used actively, and so on and so forth. Once you assess, then you know that what is the security posture, then typically the prioritization happens through various attributes. But very few would look at it from the adversary perspective. And what we have is adversary-driven prioritization. So you can, instead of going through the reports and Excel sheets, if you can visualize, okay, how an adversary can enter and penetrate into your enterprise, then you can better prioritize your remediation measures. And there are certain assets which you may not be able to remediate fast. So you need a mechanism by which you can mitigate the risk around those assets. So it could be you put some mitigation controls in terms of network containment or some configuration changes, so on and so forth. So what essentially it is doing is taking you from manual and archaic processes of prioritization into a visual representation which can help you fast assess the data and take the actions. So this is just from where all we can ingest and discover the assets from external assets and exposures. We can also discover assets from by using the Falcon sensor, which is the agent. We can discover assets, we can discover accounts, we can discover applications. We can also ingest assets from third-party databases, which your CMDB or other systems that you may have, and account events that we have from Falcon. And we integrate those. We can identify different types of assets. We can identify endpoints, IoT, OT devices, cloud workloads, cloud resources, identity and accounts. And we can model those in something what we call as asset graph, so that it can help you visualize better. And then you can assess the risk on it. You can establish connections and the paths which are there across these assets. And now you can analyze them better. So this is what it looks like. Now this is actually what is there in the product. It's not just the picture, okay? But as you can see, the first thing that you want to know is how exposed I am and through which assets I am exposed to the internet. So we have something called as external attack surface management, okay? Then once you know what are those assets that are exposed, then you want to understand what are those assets which are crown jewels and which are at risk. Because if somebody enters and gets to those assets, then you have a problem, right? And from the exposed assets to the assets as at risk, which is internal critical assets, how an adversary can traverse through your organization. In that traversal path, what are the risky assets? What is the intrusion risk on those assets? And then once you have gotten the paths, you have gotten the intrusion risk, now it is a better way for you to prioritize. For example, if you see the assets there, if you mitigate the vulnerabilities or if you fix the vulnerabilities or misconfigurations on those assets, then you actually close that path for the adversary. And you can say that you have reduced the risk. So these are various, it's a process aspect as well as the product aspect by which you can reduce the risk and actively block the adversary from either entering or after entering, performing their activity in your organization. Chetan, if you can. Okay, so as I had mentioned, there are different ways by which you can protect your organization, but CrowdStrike is in a unique position to provide you both proactive security as well as it is coupled with an active protection, so that you can either defend the adversaries from entering your organization, or if they enter, then make sure that they can not do their activities while they are into organization, and then you can get rid of them. Thank you.
Okay, I know I have 10 minutes. Organizers, please give me time check. I don't have a clock. Okay, so I was wondering what to talk about in this context. So I thought, you know what, the best thing to do is be honest. I will talk about things I work on my team works on. So that is CrowdStrike's AI and ML strategy. Next. So this is, of course, just a visual view of how long CrowdStrike has been doing things, having solutions with AI. You can see it starts from 2011. 2019 is when I joined, and a lot of things have happened since, and it's extremely exciting. And I'll probably touch upon those in the subsequent slides, especially the latest ones. The next one. Okay, so this is an academic institution, of course. This always worries me. What is AI? What is ML? What is deep learning? Honestly, I can't even tell you that I know for sure. So we are laying the foundation here. This is what we call AI, the space of technology that trains machines to imitate or simulate human intelligence processes in real-world environments. And machine learning, a subset of that, which refers to the process of teaching algorithms, having models, and then to solve and predict things on data. Yeah, next one. So why do we use AI? So we are CrowdStrike. It's a large company, so we don't do it just because it's fancy or it's the in thing or vogue. Because we really need it. We need to analyze large volumes of data. We need to do it with speed and accuracy, and that cannot be done with human. Like what you guys said, there's so much of data, telemetry data coming in that you really cannot do it manually. Where is AI great at? It really is great at uncovering patterns. That is very hidden to us. Humans have biases. AI helps reduce that. And where it is best is that's what part of my team does, is automate repetitive and manual tasks. It's really boring to do the same thing again and again. That's where it helps. Next one. So this is what a typical, a model looks like. There is an unknown sample that comes in. The model, we have analysis. The model performs analysis on this. Ultimately, it predicts, is it malicious or is it not? And then the next steps are automated remediation or alerting a SOC. It can be anybody. So that there can be different processes there. Where we really worry about is having the efficacy of a model, and we really want high fidelity detections. And I won't test your intelligence by going through what is a false positive, what's a false negative, what's a true positive, what's a true negative. Most of you know that. But each of this has pros and cons. We obviously want true positives to be maximized. False positive is a huge problem, and false negatives even worse. Like he said, we stop breaches and then that goes wrong. Yeah, next. So what we really strive to do is we have where we want to maximize the true positives, at the same time minimize the false positive. Easy to say, it's a very difficult art science. And because if you have false positives, because if you have to do it for a certain solution space, let's say I want to do valid certification. We have external certification partners we work with. There are things, we can be incentivized to just have a very high true positive value. We catch everything you throw at us, including benign programs. That will look great on a certification. Is it right for the customers? Because then we have a problem, because there are people there, their workflows get disrupted, it's extremely expensive, there's a lot of money which goes, so this is a big problem we try to solve. Yeah, next one. I'll probably skip this in interest of time. Okay, so this is where, I'm very much involved personally in this. So in a lot of this, I won't say all, the whole company does this. But where we really pride ourselves is we have a role of a human and the role of AI and of the machine, and both have to be in sync and both have to go in parallel for us to have best outcomes for customers. Because what does the machine do? So we have automated data enrichment labeling. AI is great data makes great AI. That's simple. All of you know that. So data enrichment and labeling, inference analysis, measuring the performance, whether the efficacy of a model or the performance of a model itself on the sensor or the cloud, wherever it might be, and automated, all that can be done by a machine. Where a human comes in is actually entering into the recipe of what makes a great model, right? It's almost like a chef. So one, you need to curate the data set. You need to know what you're trying to solve. You need to find the right model for it. You need to define the features in the model. Then of course you have to test it, then you have to scan it, then you have to tune it, and it's fun, to be honest. Then of course you need to know what's happening in the real world. You need to find the new threats out there, and you need to work and label those so that it gets into the next training set. So these are the steps in a typical thing that happen. But when it runs at scale, it's amazing. When you have trillions of events daily coming in and you have high fidelity detections at the end of this, that's a mission accomplished. Next one. Okay, so almost all people in the industry, I think, on the pre-execution detections, I think everybody's probably great, right? Everybody, I think by now people have solved it, and it's tough, but they still solved it. So we do that, whether it's on the sensor, models tuned for sensor, for performance, for speed, or on the cloud, where resources is a lot more available, where you can take time and things like that. We also do things like behavioral analysis at runtime, which we pioneered, because this is great because, well, you can have even behavioral composition where you have a static model say something, then you look at the behavior, then you say, you know what, if I compose those together, it gets that much of a high fidelity one. And the remediation aspect, this is great because the threat hunting, which goes out, the people who actually look at, what should I say? I'll dumb it down. I'll say hackers out there. When they're actually hands on keyboard, when that happens, the threat hunters sort of take a look. They sort of react to it. There's stealthy attacks out there, and of course, we also have something called crowd score, which actually shows you real time what's happening. You might just have a file copy. You might have something on itself. It's nothing, but seen in the context, in the sequence of things, the threat level sort of goes up, and then you know what, something bad is happening. So these are the sort of various boxes that we work in. Next one. Yeah, so this is working in security is easy, is it not? I mean, there are good things and the bad things. The good thing is, you have good job security if you're good at it. I dare say the pay is pretty good if you're good at it. There are a lot of bad things, late nights, stress, less friends, constantly shifting landscape. Yeah, it has its pros and cons. So we need to do anybody, not we, I'm not talking about CrowdStrike. Anybody who needs to protect, they need to do all these all these things on the left. We need to triage very quickly, like Yogesh brought that up, because the average breakout time is 84 minutes. If you look at our CrowdStrike threat report, you'll see that some, I don't want to name them, but let's say Russian adversaries can actually do it in 17 minutes. That's incredible. To get into your network, do what they want, pull it out and get out in 17 minutes is incredible. To sort of triage that fast, to defend them so quickly, to take remediative actions, to do more with less, as we say, is what, that's our mission. Next one. So this is, of course, something that, if you see the booth, you'll see Charlotte, who's our generative AI. So that is something we released this week in our Falcon conference. So this is, of course, LLMs. You must have heard, I heard that a couple of times in the morning talks. So this is, of course, something we have started with. So there's so many places where LLMs, it's, of course, a new space, it's evolving, we're all learning. But yes, there's so many things where it is great at, generate content, data retrieval, especially natural language summarization and explainability. That's a huge problem, right? I mean, imagine having a 100-page report and giving it to a SOC analyst and say, analyze it in 5 minutes for me. It's not even possible, right? So there are a lot of places where we think there is tremendous scope for LLM. There is one specific, go to the next one. I don't know if they have that. Yeah, next one. This is, So maybe next one at the use case I think I have. Okay, this one. So this is where we have already generated this, where we can have analysts look at Falcon, sort of use Charlotte and say, show me all the machines which not patched. Show me all the machines with OS which is old. Tell me the machines which have vulnerabilities exposed. Tell me which is not checked in some time, in a verbal interactive manner. Go to the next one. So this is how it is. Nobody. I know you can't read the text of how Charlotte is answering, but it's pretty much things like that. Real-time assessment, like the examples I gave. Do you have vulnerabilities on Microsoft Outlook? It gives you an answer in a few seconds. The biggest risk that you see: are you protected against a certain vulnerability? Say Log4j, whatever it might be, things like that. So next one. I think we have 3 slides saying the same things about different use cases. So that's sort of what I wanted to say. I know I had to really rush through in the interest of time, but I sort of hoped I could give you some sense of what it is we do. Because I also heard in the morning, India mentioned a few times, India office mentioned it 2 times. So Yogesh and I are not here just to talk about the company. We are, of course. It's a company product. We're also talking about things that we build with teams based in India. So that's something we are really proud of. That's sort of what I am. Yeah, sure.
In my basic thing is, you mentioned about ML being used for detection processes and all that.
Right.
Where did you get this training set? Or is it an open source thing, or you had your own data builder?
Okay, It's a great question. I need to be careful that I don't let out, but a mix of both, to be honest with you. And we call ourselves CrowdStrike the crowd. To be honest, we need the crowd in the whole security space. So it's very much something that we have community building, like Virus Total, for instance. There are feeds for sale, sample feeds that are for sale, sample feeds for subscription. People do it. So it's collaboration at a large scale. But to really get the niche, the corners, so everybody's in the same space. Most people probably get 97% false positive with 1% false negative. To sort of inch ahead of our competitors, some of who are sitting here, that is when we sort of build our own samples. We sort of know what the problems are, and we sort of, for adversarial attacks or whatever it might be. That is when we have to do both, and we do both.
So let's say you had some crowd source and you got some data from these guys.
Right.
How much did you rely? You obviously had some confidence, in that you were totally trying to read it, or
It's a great question. To be honest with you, we take it with a pinch of salt, right? So we need to have so many guardrails in mind where you can have competitors who just want to trip you, right? On purpose, they just say, that's a malware. And for all you know, it's one of the most used softwares in Windows OS. So that's something we really take care of. And that's where using multiple guardrails, by knowledge, by their own reputation and things like that, you sort of lessen the problem. I wouldn't say the problem goes away. Anything else, sir? We know, not you. Okay.
Just by using internet connections, right?
Yeah.
Just by using internet connections that your program is doing to the outside world, how much we can really capture? The reason I'm asking is basically actually this problem is not only for enterprises, it's even for end users. But ultimately it has got to do with malware sending the information to some unknown systems, right? So
honestly, I'll be honest here, network protection, that space is not something I deal with personally, Vinod. So I will need to sort of hand wave.
learning from that, where I'm sending out the connection, that itself is good amount.
That itself is certainly a big, it's a big, yes, that sort of helps, the crowds, that certainly is a big variable, let's put it that way. It certainly is.
No, I think, so basically, other thing is knowing where you are sending the information and where you are sending the information, is it legit or is it something hidden behind what you are shown as you are sending to. Yeah, so that monitoring and other aspects are critical.
I don't see any other hands, so thank you so much.
Okay, we will be at the booth. So if there are any questions, we can. Thank you for giving us the opportunity.
We request Mukul Joshi to join us on stage to felicitate CrowdStrike team. Moving on, we would next like to invite Mr. Yogesh Nagapalli and Mr. Sandeep Kothale from HSBC to come up on stage.
Hello, very good afternoon. I hope this is not a session after lunch where everybody is feeling sleepy or something like that, right? So, I'm Sandeep Kothale. I'm part of HSBC, and I've got my colleague Yogesh. I'm working as a blockchain delivery lead for all digital assets initiatives globally for HSBC, and I've got Yogesh, who is our enterprise architecture. So today we are going to present about a DLT initiative which we started 1.5 years back. So the platform name is HSBC Orion. So before I deep dive into this, I would just like to share some more details about our asset class. So from HSBC, we are working as part of markets and security services. So this security is not the cyber security. Yes, this is all things associated with equities, bonds, your debt instruments, derivatives, and so on. Right. So please don't confuse this with the security which we have been listening since this morning. Right. So about the platform, before I talk about the platform, from digital assets and currencies, which is DAC, is what is our sub-asset class. So the whole focus on digital assets and digital currencies is getting a lot of traction in the market from different incumbents, fintechs, financial institutions, maybe regulatory institutions, and so on. So as a part of Center of Excellence, we started working on this initiative back in 2021, when I think in morning's presentation there was a slide which was shared by earlier panelists where they talked about Banque de France and HSBC initiative, right? So I think that was something before we started with this product. So this whole product is built completely in-house within HSBC. And I'm just going to share some more details with this before. So let me quickly go through the agenda. So digital assets, yeah, since morning we haven't discussed anything about digital assets, so I'm quickly going to spend some time on this. I was talking to Shridhar, and Shridhar said from engineering students' curiosity perspective and engagement, this would be really great to understand how the market is evolving, right? And let me spend some time on this so that we understand how the business is looking at digital assets, digital currencies. We all know a lot of initiatives have been happening throughout the world on cryptocurrencies, crypto stable coins, central bank digital currencies, and so on, right? So I will also spend some time on business overview, some business benefits around DAC, digital assets and digital currencies, and then I will hand over to Yogesh to deep dive into some technical stuff. So yeah, from definition perspective, this is what you see on the screen. Digital asset is not something which is completely new. We know Bitcoin exists since 2008. Then why suddenly this started coming up only now? In interest of time, Mukul, please stop me, please help me to stay on track from schedule perspective. So yes, it is a cryptographically secured digital asset or digital representation, and which have a value or contractual obligation associated with it. Now, just to spend something on digital asset, there are three legs to it. One is your blockchain network. We all studied permissionless networks, So how do these networks interact with different types of digital assets? Now, these types of assets are classified into normally 4 different categories. Bitcoins and ethers, which are cryptocurrencies. Then we have stable coins. Then we have central bank digital currency. And finally, the tokenized assets. From HSBC perspective, yes, we are not involved in cryptocurrencies because of the consensus algorithms and our commitment towards go green. So that's not our focus. Our focus is using the technology to solve business problems and get efficiencies in the business process. At the end of the day, we are client driven, right? Our whole initiatives are based on client sponsors. So just to spend some time on market size, this is what World Economic Forum and Boston Consulting Group have been estimating. So there's estimation is like almost by 2030, it will be a 16 trillion of assets which will be on digital, which will be digital assets, right, in the market, which is almost 10% of global GDP. So it's a huge number. And that is what is motivating business or motivating financial institutions to generate their interest into this. There are a lot of institutional investors who are curious to invest into digital assets. We see almost like 90% of institutional investors are intending to invest into the digital assets within the next 5 years. Now it includes different types of assets, which includes listed equity, unlisted equities, investment funds, your bonds, home equities, and so on. Now, this projection just gives us some numbers in terms of why business is really looking for this and interested in it. Now, from platform perspective, HSBC Orion, as I mentioned earlier, we worked with Banque de France. We as in HSBC Security Services business worked with Banque de France, where we did an experiment with them on central bank digital currency using the interoperability protocol on blockchain, the Weaver protocol, which Shishir was talking about this morning, right? So after that initiative, EIB started, we started engaging with EIB, where EIB appointed different custodians. Now, the idea was to see how do we get the efficiencies around current processes in the market, reduce the trading time from T+2 to T+1 to T+0, how do technology can help us on getting and achieving this. So this $100 million of bond was, Euro bond was issued on the platform for 2 years with coupon rates, with notes executed in 2021. At the bottom of the slide, you see a note which has been published by EIB in the public news. The excitement is more not only because of technology stuff, but it's also because this is something which is happening in industry. Like it is the real thing, real money which is getting traded on blockchain. Right? From technology perspective, and just some bullet points on the right-hand side, we used a hybrid blockchain here, public-private networks or public-private blockchains talking to each other. The legal ownership sits on the private blockchain, which addresses a lot of concerns from HSBC and regulatory perspective. All the implementation has been done by staying within the boundaries of and the governance which has been established by the bank, right? So I mentioned 3 different custodians who were appointed here. HSBC was one of them, BNP Paribas was another, and RBC Capital was a third one. So European Investment Bank worked together with all 3 of them, and HSBC Orion was used to launch the bond on the platform. So from functional perspective, the whole bond life cycle was performed on the platform, where the issuance is completely done on the platform itself. Coupon payments could be initiated using the platform, where we have introduced a term called as settlement tokens, right? Which is not exactly the stable coin, but that helps us to achieve an instant DVP and reduce the settlement cycles. Another important thing is the bond do not sit onto any intermediary like CSDs. There is no central security depository involved here, which makes the platform as an legal owner of issuing the bond and allocating the ownership between different participants on the network. So what is this platform all about, right? So from HSBC strategic initiative, asset tokenization is what our main focus is on. And this is more aligned, this platform build is more aligned with this strategic initiative. We, as I mentioned earlier, it's a hybrid blockchain where the legal ownership sits on the private blockchain network, and the public network or public blockchain network is used for the memo tokens, right, which is available for the public view. Okay. I'm not going to, in interest of time, I'm not going to spend time on investors. I know not much institutional investors are sitting here, but there are some bullet points why institutional investors are really interested in the platform. Right. There are some, definitely from benefits perspective, there are multiple participants involved on the network, right, from issuers to investors to custodians and regulators. All of these participants have their own benefits, right, from efficiency to cryptographically secured information stored on the network, necessary information available only to the required participant on need-to-know basis, and so on. Right. I'm going to take a pause here, and I'm going to pass on to Yogesh, who can cover the next piece on architecture.
Hello everyone, I hope you are still awake. So I'm Yogesh Nagulpalli. I'm leading enterprise architect supporting DAX UE as Sandeep is leading. So this is the high level architecture that you see, which is maybe 30,000 feet high. Sandeep talked about a combination of private and public blockchain. So private blockchain is something which is sitting in our secure environment, which is protected by all firewalls and whitelisting, whatever you can think of, that is kind of sitting in our environment. And we are allowing stakeholders, users to come into our platform and use through traditional channels, like it could be UI, it could be Swift, that they could be sending. So that's all sitting in our kind of our environment, overarching the private blockchain itself, right? And private blockchain, as you know it, I mean, it is kind of permissioned. So participants who want to be part of the network needs to have a node on that network. So we have like different nodes for different stakeholders onto that platform. Some of the stakeholders which are mentioned like issuer, custodians. So Sandeep talked about different stakeholders like BNP, RBC. So they have their own nodes on the network, and they are exchanging data as part of that network. What we are also doing is, because it's a bond issuance platform, so it does primary issuance of the bond and also allows for you to do secondary trading. So let's say there could be, let's say, exchange of trades between different parties. So they can do that on this platform. And as part of that, we are doing the DVP, delivery versus payment. So we would get, let's say, money from their fiat account, which could be, let's say, our core banking platform, and it would then issue settlement token, which is then used for doing the DVP. Now, all this is represented in our private blockchain, and I will take you to what that structure looks like in terms of the account structure and the tokens in the next slide. So left-hand side is talking mainly about private blockchain, and right-hand side is the public blockchain. So here we are posting the memo. So whatever ownership, token ownership we have, or the bond ownership we have on the private blockchain is posted to, let's say, Ethereum. And that's only for, I think it doesn't have any legal standing. It is only a choice given to investors just to see their ownership on Ethereum, right? However, our golden source is still private blockchain, okay? So that's what it is. And some of the key features are, as I mentioned, we do primary issuance, that happens first time. And then we are on-chain integrated our payment solution also. The settlement token which gets issued is by that solution. Tomorrow it is settlement token, today it is settlement token, tomorrow it can be, let's say, CBDC. Let's say if RBI decides to issue CBDC and investors want to use that CBDC, we could actually integrate into that CBDC, right? Then we are doing, because it's a bond, we need to do coupon payment, so we are providing that asset servicing as part of the solution. Yeah, and as I told you about secondary market, so there could be, let's say, trade coming in as part of, let's say, OTC trade. Yeah, and I already talked about public blockchain connectivity, so we are posting bond token ownership onto Ethereum. Okay. Next slide. Okay. So this is about account structure and different tokens that we mentioned. So account, here there are different parties or stakeholders. One is CAK. So HSBC is playing role of a CAK, which is managing the platform itself. And then there are secondary account keepers. They are nothing but, let's say, custodian. So each of them have accounts on the platform. So it's called two-tier account, where CAK has an account and SEK also has an account. And the tokens, there are 4 types of tokens. One is issuance. So at the time of, let's say, primary issuance, those tokens are issued. So those are called issuance tokens. Digital bond token is nothing but what gets issued to, let's say, individual investors into their segregated accounts. And settlement token, as I mentioned, those are like fiat money converted into a token which gets exchanged with the bond itself, okay, at the time of issuance. And digital bond information is something which is published on the Ethereum. So these are kind of 4 tokens that we publish. That was our current state, and obviously we want to expand our footprint into going into different markets, attracting new custodians, embracing new currencies. So today it's, let's say it is euro, tomorrow it could be any other currency. That way we can go into. We want to connect to different trading venues so that secondary trade is facilitated. And obviously we want to make it, as we add more custodians, we want to make it more and more distributed so that new custodians can be onboarded onto the platform. So yeah, I think that's it. Any questions on the, maybe you can come over.
Any questions?
Any questions from anyone?
Do you use Ethereum as the public blockchain?
Yes, yes.
That's exactly. It was a business call. It was a business decision which we took at that time, and the idea was that at least, okay, there's a background to this. So background is that maybe from future perspective, we see that financial institutions are going more towards public blockchain. Not all use cases can go on public blockchain, but yes, some aspect of some use cases can go on public blockchain. And in that case, we wanted to establish this proof of concept in a real world where the real money gets transacted on public blockchain. So as I mentioned earlier, the legal ownership of the bond sits on the private blockchain, but on public blockchain it is more like memo token. So for now we are okay to spend that extra money because the volume is really less. Any other question?
It's a bond, yeah.
No, all the bonds have to be tokenized. You cannot have some bonds non-tokenized.
No, that's not mandatory. So we decided that a specific selected bond with a specific market under Luxembourg law was published on a platform.
So I think in this case it was, I think, Mona, right?
Yeah.
Mona bond. So name of the bond is Mona, which was digital native. So it was issued on blockchain. So all the transactions on that bond will happen on DLT, right? Tomorrow, if you want to issue another bond, maybe, I mean, that can also be on the, yeah.
One thing which I would like to add is talking to Mukul, Shridhar on trust, we see multiple parties involved here, right? And all of these participants on the network, there is definitely a trust issue. At the end of the day, it's a real money which is getting transacted. It's millions of dollars, right? So how that trust issue is resolved without using an intermediary like depositories. I think that's what the whole use case was focused on. And Shridhar, to your point, I think the market size which we mentioned can really attract some more engineering talent on all the things which we have been doing, which is not only from POC and research perspective, but it's more commercialization, and that's what business is looking forward for. So I hope that generates some interest in, and you help us to pass on that interest out there. Okay, okay. Thank you all. Okay. It was great presenting to you.
Thank you.
So we once again request Mr. Mukul to join us and felicitate our sponsor. So a big thank you to our sponsor for their support and participation. Your partnership is truly appreciated, and it plays a significant role in making this event a success. Now, moving on to the next panel discussion of our agenda.
So in today's digital era, the intersection of society and digital trust has become a subject of paramount importance. It's time to introduce the members of our fourth panel, Society and Digital Trust. In this session, we will explore a wide range of topics, providing you with insights of how trust operates within the fabric of society in the digital era. So our fourth panel includes Mr. Shailesh Gandhi from Satyameva Jayate, Professor Debayan Gupta from Ashoka University, Mr. Manish Kumar from RealX, and Mr. Rohit Srivastwa from Cast Cyber Ventures. So please join us on stage. And ensuring a stimulating and insightful discussion is our moderator, Professor Akshay S., representing the IIT Bombay Trust Lab. So we request Professor Akshay to join us. So Professor Akshay is currently an associate professor in the Department of Computer Science and Engineering at IIT Bombay. His research interests encompass a wide spectrum of formal methods with a particular emphasis on the verification of timed, recursive, and distributed systems, automated functional synthesis, and the formal modeling and analysis of probabilistic and dynamical systems. So the floor is yours, sir.
Thanks. Go ahead. I guess both the mics are working, right? That the hand mics as well in this, all right? Okay, great. Welcome everyone to this last but one session on society and digital trust. We have a very illustrious set of participants, and it's my pleasure to be the moderator this afternoon. So in Digital Trust Lab, we've been hearing a lot of technical talks about many technical topics, including deep tech and so on in the morning, as well as industry collaborations and so on. And I think one of the aspects which is also a focus of the Digital Trust Lab has been the interaction with society and governance issues and policy issues. And today's panel, this panel is going to touch upon some of these issues, which is not only on the technological applications, but also challenges societal applications and challenges when technology, digital trust technologies especially, are being applied in our society. In this panel, we will touch upon a broad spectrum of these. So let me quickly give you first, what shall I say, a short introduction about our illustrious speakers, and then tell you about what we're going to do here. Is there a revised timeline, or do we go with the same time as before? All right. Excellent. All right. So we have as much time as we were promised. Okay. Yes. So the first speaker would be Professor Shailesh Gandhi, who likes to call himself a citizen empowered by RTI, right? And he has been the convener of National Campaign for People's Right to Information Act. He was also a Chief Information Commissioner, and he will. Okay, simple. Okay, Central Information Commissioner. Thank you. And he is, among many other things, in 2010, IIT Kanpur conferred him the prestigious Satyendra K. Dubey Memorial Award for his exemplary dedication in spreading communal harmony and leading the RTI campaign. We also have Debayan Gupta, who is from Ashoka University. He is an assistant professor and also, I guess, a research associate still at MIT. Debayan held a faculty position at MIT, and also, I think his primary areas of interest include secure computation, cryptography, privacy. He has started several companies and startups, and also consults on cybersecurity and cyber risk. We also have Manish Kumar from RealX, and he describes himself as a disruptive serial entrepreneur, maybe, and with many years, at least 2 decades of experience on building participative platforms for participative growth. And he will, he is also a member of a few consultative committees on blockchain, and we've had several things on blockchain in last 2 days, and I'm hoping that he'll touch upon those issues as well as we go on. And finally, we have Rohit Srivastwa from KS Cyber Ventures, a serial entrepreneur, a recipient of Microsoft MVP Award on enterprise security, and he has been a liaison member at First.org, which is a consortium on computer emergency response teams across the globe. He has done several other things, too many to list here, and we will also run out of time. So he has also recently co-authored a book on personal data security and privacies for techies and non-techies, called My Data, My Privacy, My Choice. So let's all welcome the panelists. So today we were thinking about how to organize this session. So I think what we will try to do is to have an initial address by each of the members, and then we will open up we will have some discussion between the members, and then open up for questions, and hopefully this will take us through the hour. We'll start with some issues on digital governance, in particular transparency issues by Shailesh Gandhi, who will address us, and then move on to the larger question of digital trust, privacy, and security in the society. Then we will look at 2 cases of trust in digital trust systems. One is on financial services, and the other will be on recent technologies such as QR codes, passphrases, and so on. So this would be kind of our starting point, and then I hope to have an enriching session with all of you. Thanks. You could just sit here and as you please. Oh, you prefer that? Okay.
Fellow citizens of India, various talks have been there since yesterday's workshop, all on technical aspects of digital security, digital privacy, I'm going to talk about a very mundane thing, a very pedestrian thing, saying digital to karo pehle. And I'm talking of the governance of India. We say we've got digital. We have the latest Aadhaar, we have the latest UPI, everything. But how does my government work? Let me describe a very simple daily feature. An average citizen goes to a government office to pursue an application or complaint or representation, and he may be told file nahi milta hai. 200 रुपया दिया तो फाइल मिल जाएगी, 500 दिया तो रिकॉर्ड चेंज हो जाएगा, 2000 दिया तो फाइल गायब हो जाएगी. This is the state at which it operates. And how much time does the file take to travel? Chandrayaan reached the moon in 40 days. Aditya, we know, is likely to reach 1.5 million kilometers away in about 110 days. But a file can take innumerable time, depending on the money put on it. We can't forecast the time and travel of a file. We have corruption. We have absolutely nothing called digitization in government. The name of digitization is given to scanning papers. When I reached the Central Information Commission, I was told we have to digitize. So what did it involve? Getting a contractor after the files were over to scan all the files. And nobody used the output. I changed that slightly and said all the papers that have to come to my office must get scanned first, and we'll make the file electronically. And it worked beautifully well, very efficiently, and it can work in government. For 2 years, I made it work without any software support, with no budget, nothing. Just on a simple desire saying that it must operate. And if it operates like that, what are the advantages? Changes cannot be made very easily in the files. If they are made, they can be traced as to who made it and so on and so forth. You do not need kilometers of space to keep files. The government spends thousands of crores of rupees on paper, files, space to keep these files, and a comparable amount to locate these files, because they can't find the files usually. Chori hona easy hai. It's very simple to manipulate files. For transparency, we often blame the poor public information officer. But the truth is the files just cannot be found. Electronically, all this would become a dream. But we don't do it. And my angst is that nobody is really talking of this as an agenda of the nation. It's too mundane. My government working on electronic systems is so mundane a topic. It doesn't attract academics, it doesn't attract the industry, it does not attract the media. So who's going to build the cat? The savings would be enormous. At least 30% to 40% of India's corruption would go down just by going electronic, and it doesn't take much time. There's nothing great required. But we are not doing it. Why is the question that I'm wanting to pose before this place. I'm saying trust in governance will improve tremendously. What I'm saying is nothing new. It is no rocket science. It's ordinary common sense. Will we do it? Before I end, because the time is short, I'd like to describe how electronic digitization is happening in a lot of places. Supreme Court has had an e-committee for the courts since 2005. Our current Chief Justice was the chairman of the Supreme Court e-committee. Bombay High Court until last year said we become an e-court. So what did they do? Your petition will not be accepted unless it is sent by email. Fair enough, so you send it by email. But nothing will move unless you submit the hard copy. And then there are corrections, etc. So the hard copy is then scanned. And nobody uses the output of the scanned copies. What is used is the paper files. We are today at the forefront of the digital revolution in the world. We are talking of trust. Can we improve trust in our own government? And what can you do? I found in a survey that most Indian citizens crib for about 3 to 4 hours every month about what is wrong with India. My submission to you is, if you are convinced, spend 1 hour out of that time. Continue cribbing the rest of the time if it's good for your mental and physical health. 1 hour of that time, write a blog, talk to 5 people, talk to industry, talk to departments, and get them to start discussing this as to why we can't do it, and we can do this within a year or 2. It's not difficult. It needs no change in laws. It needs no change. All it needs is a will to do it, and that will is lacking. And citizens and media are not concerned. This is a charge I'm making. It's not the political class. It's we who are to blame. We say, this democracy, we are Badshahs and Begums of this democracy, but we've gone to sleep. Think of it. Try and start doing something. 1 hour every month. Take out of your crib time to do something. And India can change. India will change. Thank you. Thank you very much.
Hello. Can you hear me? Yeah. Thanks a lot, Shailesh. Maybe we can have the next talk by Debayan. We'll have all the addresses and then we'll open up the floor for questions. Is that fine? Or? Yeah, please. So if you have questions for the panel, please note them down and keep them ready. We will come to them. Yeah.
Sure. So I'm actually going to start with 2 things. I'm going to start with a Supreme Court judgment from a few years ago. I'm just going to read out a couple of lines from it. Privacy is the ultimate expression of the sanctity of the individual. It is a constitutional value which straddles across a spectrum of fundamental rights and protects for the individual a zone of choice and self-determination. This is our Supreme Court. I strongly recommend everyone, especially the cryptographers, go read the Puttaswamy judgment in full. If you don't have time to read the whole judgment, I also recommend there's a very good blog by this chap called Gautam Bhatia. There's a very famous mathematician, Rajendra Bhatia. His son Gautam is a very good lawyer. There's this constitutional blog where he analyzes all of this stuff. We have some excellent judgments and conceptions around societal trust in the government, in the mechanisms of these systems, as well as our understanding of privacy. The problem is, it's written down somewhere, nothing happens on the ground, right? I came here to this meeting for the Trust Lab. The first thing that happened was I checked into a hotel. The hotel guy said, climate change, we're stopping all plastic. I'm like, okay. And therefore, in order to check you into your room, in order for you to get into your room, you have to install an app on your phone, right? It's 1 a.m., I don't have time. I'm like, okay. The guy takes my phone. So after you install the app, he has to enter a code. So he enters a code and he starts tapping away at all the permissions, location permission, this, that, and the other. And you have no choice because the app won't work without it, right? And you can't get into your room at 1:30 a.m. without that app on your phone. This entire story about informed consent is a joke. So how do we expect people to trust systems when it doesn't matter whether you say yes or no, you kind of have to say yes. And even if you say no, like Google reporting on your locations on Android, even if you did say no a few years back, it doesn't matter, right? The second thing is that even if, suppose I am a complete layperson, and suppose all the clever cryptographers here come up with some fantastic protocols, I see essentially a binary, an executable, an output. How do I trust that object? I'm not about to sit and decompile it. Most of it's proprietary anyway. So where does my trust in that object come from? It is built up using societal interactions over time. It's not just a short-term object saying, oh, here's a cryptographic proof, right? That convinces the cryptographers, which is a great first step. It's important to have. But then how do you get it to the next level, right? Second, I want to contend that just because for us, sort of computer scientists, it's easy to say that, okay, when we do the math, the worst thing that can happen is someone breaks indistinguishability or the secret leaks, right? And we say, therefore, this is insecure. What is the actual outcome of that insecurity is very interesting to see. Now, generally speaking, and here I'm drawing on mainly 2 legal scholars, Peter Swire and Daniel Solov, there are 2 conceptions of this. One is the one we are familiar with, the Orwellian surveillance state. We're saying that we're leaking data. There's some person sitting up top there who's gathering all of the data up, and that person is going to get us into trouble somehow if we do something that the powers that be dislike. That is one setup. Solov argues in the other direction, which is echoed by Puttaswamy in India as well, which says the greatest problems with individuals in their everyday lives, as well as the attacks on privacy, actually come not from surveillance, but from what they call inappropriate data flows, right? And this is perhaps epitomized by the famous book, The Trial by Franz Kafka, where this guy Joseph wakes up, there's two officers standing in front of him, and they say, "You're on trial, sir." And he's like, "For what? I haven't done anything." Like, "Well, we don't know, but we know that you're on trial and you must be arrested." That is the extent of our knowledge. Everything else is private, right? By the way, when we cryptographers say it's zero knowledge, right? It's very, very private. When we cryptographers say privacy, we actually mean secrecy. And these two are very, very different things, by the way. The Indian Supreme Court's conception of privacy includes, for example, compelled speech. So if a person forces me to say the word yellow 15 times, that is part of that story. It includes things like forced feeding, right? So like, the problem is that we do math assuming certain things. And if the law of the land, the assumptions around trust, privacy, all of these things don't align, then all that will happen is that a certain number of people will read our papers, we get our citations, and that's the end of it, right? I do want to poke at one problem, which I hope many of you will think about after this is all over, which is, this is my favorite example for talking about this. I may have hopped on with some of you about this already, so apologies for the double thing. I want to emphasize that thinking about privacy and trust and when these things break is very difficult to do with rule-based thought. So our entire legal system and a lot of our thinking in even tech is based on rule-based thought. Here are 14 things that are allowed, here are 5 things that are not allowed, right? Legally, you're allowed to turn left here, you're not allowed to turn right there. Mathematically, these two things must be indistinguishable, universally in UC, whatever, blah, blah, blah. You write everything down. The problem is that in real life, just as I talked about my consent scenario, when you're talking to your doctor, when you're doing a lot of stuff, you don't really have consent. You don't have a choice. You're not an independent individual anymore. And therefore, we need to find some way to talk about purpose limitation, right? Not just one layer of thought. And this purpose limitation, I want to talk about one small example, which is automated license plate readers. These are these small cameras which read your license plate number. If you blow a red light or something, you get a ticket in the mail a few days later. These were grandfathered in because they automate away a simple thing, the police person standing by the side of the road, writing down your car number as you speed past. Now the problem is you gave them functionality X. What is functionality X? This ability to write down your number. You have no expectation of privacy because you're on the road, it's open. You're in public by definition. With 100,000 of these, Delhi has more than that number of a single company that I know of. Mumbai also has a huge number of these. Police can access your location without a warrant. I can track your car. Now, if I asked you, is someone allowed to put a GPS tracker on your car without a warrant? You'd probably say no. So the problem is you gave them permission to get X functionality, but they managed to get Y functionality, right? This is extremely common in machine learning. You think you gave them a picture of your eyes, Microsoft tells them, no, you actually learned about this person's heart health, right? So this functionality creep sort of is very, very difficult to deal with. You can't pre-make laws and therefore policy is permanently stuck trying to catch up with technology. And we need very strong purpose limitation regulations ahead in order to even think about fighting this. I don't know the solution to this. Maybe we can have a fun discussion around that.
Thanks a lot, Debayan. We will move on to the third speaker. Manish will talk to us. Yeah, I think Manish has a presentation.
Yeah, so I'm thankful that since yesterday all the deliberations went more and more mathematical, and probably we have finally landed on the application layer of things. So we are talking sense and common sense. My realm, my limited realm of things are a lot easier than governance, a lot easier than abstract law. My realm of things is real world digital assets, and a limited larger scope that I would like to delve upon also will be around regulations and how we are kind of privileged in some sense that financial regulators are slightly more specific, and it has evolved in a kind of a stricter domain. So you have things that you can learn from, you have things that you can copy from, even if you're starting anew, and those gaps and crevices are constantly being fixed by regulators. So there is what is something called prudential regulations that one can look up to when you are doing something in financial services. So in that sense, the trust factor, has a certain north star, so to say, to go to. My platform is called RealX. We are a platform for fractional ownership of properties, the biggest asset class in the world, which has yet to be held in digital format. Our claim to fame is that sometime back, about a month back, we closed the first transaction which encapsulated direct digital, direct rights, direct beneficial rights over the property inside an NFT. So, and I'm talking about rights that are legally enforceable in courts of law. Now, this is something that there are two worlds that we are trying to merge together. It has taken us years of work and probably all my life experience to bring to fore something like that. Again, coming back, before I begin my slides, and my slides are slightly more restrictive towards the challenges in bringing the whole ecosystem together. What does it take to bring out a real world digital asset ecosystem, which is a kind of relevant current challenge a lot of people are trying to solve. I still say that it's a lot easier in my case because there are now North Pole guidelines that we follow. Let's proceed. So what is digitization of real world assets? Digitization of assets is a process by which rights to an asset, simply put, is you are able to encapsulate the rights to an asset into a digital format, which can be cryptographically secured, and rights can be transferable and things like that. By and large, this is done on blockchain, and tomorrow some other technology also may come in and it may replace blockchain. Next one. This is a very simplified overview of what does it take to create digital assets. As in terms of process, you need to verify the asset that you are taking. You need to know what you are taking in. Then there is a sale of the asset that is required. Then the asset itself, because we are talking about a physical asset, whatever the asset may be, the asset needs to get into an asset custody arrangement. The tokens, who for the people who bought the tokens needs to be issued. And then, the life cycle, during the life cycle of the asset operations and maintenance has to be carried about. This is what I would like to talk about, for the most part. Can I have the mic? This is loaded. Yeah. So these are the challenges that we face today when we introduce something like this into the market. These are market gaps that exist that are not essentially to be fulfilled by us. And until we do some of these things, the elements of trust do not creep in. Having said that, this is North Pole arrangement exists, but then until you plug many of these gaps into that, you are not a trustable ecosystem of play. So Aadhaar has an ecosystem of play by law also backing it, and similarly everything that we see has an ecosystem play there. The challenges come from first and foremost KYC compliance. We are talking about NFT, and you are talking about many types of KYCs required for many countries, many applications, different KYC requirements. So KYC is one. Registration requirements. When we are talking about real-world digital assets, we are talking about registration complications, and we did properties, so you can understand, that complication as well. Some of the assets may require registration, some of them may not require registration, some of the use cases within the assets may require registration, some of the use cases may not require registration. Income distribution. How do you send, in our case that's a relevant question, how do you send income generated from the asset to a owner abroad? Domestically, it might still be possible, especially in countries like India, which has a very efficient payment system. But how do you send that abroad? And that's a very complicated question. Taxation laws. Now again, how is it interpreted? It may be different assessing officers, talking different language for the same asset. So these things will evolve. And I'm talking about one country. You talk different countries, it's a very different, very complicated ballgame. And I'm talking, again, coming back to trust. Each of these goes to trust. Taxation, how do you, if you can't answer this to a customer, the customer is very reluctant to come on board. That is what I'm talking about. Token custody. So, who's in custody of, they presented, HSBC presented some time back. They were talking about custody. In our case also, we need 3 custodians, and I don't have one, even one. And they had it in-house, but if I had approached them, they wouldn't have given it to us. So that's the interesting part. So you have a lot easier way going forward, because you can imagine it and you think it is doable. If I imagine it, it is very difficult. The moment you say token, a bank account will be withdrawn. Normal current account will be withdrawn. So how do you build in such a case? So token custody, custodians aren't there. They are not ready. In fact, a good outcome of all the deliberations that we have had since yesterday will be some good custodians coming up who use these cryptographic methods to secure, basic keys. If we have talked about very high profile use cases where more fault tolerance, can be done. But I am very hungry for simple use cases like, can we secure the use case, the keys today? And can we make things happen? Asset operation and maintenance, physical custody of the asset. They have physical custody of the asset, be it art, be it apples, or be it gold. It needs different kinds of custodians who are efficient in managing the custody of the assets. Then asset operations and maintenance, so if you talk about, let's say, aeroplanes, it will need a very different asset operation and maintenance from a property. So different assets, different asset operation and maintenance. And we are talking about spawning a huge industry, sub-industries that may happen. But until all of these is placed, the customer is the most scared guy. He is not going to trust you. That is what I'm trying to tell you. Foreign investment limits, until those are understood, how they apply, they are understood, and until the relaxation in that comes, as a second point. Grievance redressal, I was talking to someone some time back. Grievance redressal has to be addressed until we have some common norms, of grievance redressal. I've spoken to people from Trust Labs about these challenges that we face. Until we have something that we and other players can say that this is a common grievance redressal that we all can go to, solving by ourselves is a challenge. And if you don't solve it, you have a challenge with the customer's trust coming on board. Jurisdiction and fraud handling. How do you handle frauds when you're talking about tokens and jurisdictional challenges? Therefore, next slide, please. So yeah, this is all that I had to say around what all we think it will take to build the whole ecosystem at the very minimum for the customer to have faith and trust into an ecosystem of things that they are investing in.
Thanks a lot, Mukul. So we'll have our last presentation, a quick one, whatever the usual one, by Rohit Srivastwa. I think you, yeah.
Yes.
Have they been put?
And this works perfect. Thanks.
Good evening, everyone. It's like getting closer to the time of winding off the event and packing up for home. So let's make it a little more interesting and coming back from all the maths and science to the real life and real world. So we'll be talking about digital trust in a very quick manner, where the one-line definition is your confidence in the digital system. And it could be anything. It could be as basic as a file system management to as large as PNP kind of a problem, which I don't even understand. And then there are a lot of other mathematical things which only few people understand in the world, and the rest of the world start using it. But how much trust do you put on such kind of a system is something we'll discuss today. And it all started with this one. So Khulja Simsim was the first one where a system was blocked or protected by something, and the world thought that, okay, we have a protection mechanism, but they forgot that someone else is listening to it, and that's the real adversary we'll be talking maybe multi-decades from that point of time. Okay. Yesterday we had a very nice conversation around the whole India stack, and Sanjay, thanks to you, a lot of questions were discussed, and we were very happy to see that, okay, the way the digital transformation has happened in the country, the way we are growing, the way we are easily using the technology to do a lot of stuff, call it Aadhaar, call it the payments, or even anything, the acceptance of QR code into Bharat QR and all of that stuff. And ultimately, QR code, as we discussed, somebody somewhere did a lot of mathematics to create this method by which a barcode, kind of a one-dimension thing, two-dimension thing, is going into a proper two-dimension data store, where in the black and white garbage-looking content, you have a lot of data inside and can be used for anything. That getting accepted into India stack. So we saw a good amount of technology built by real good people being used in our daily life, starting from paying to a kirana wala to paying to a beggar on the street as well. That's what we saw in this whole QR code journey and the whole India stack. The point is, people build trust on it. Then, oh, government has launched this, it's a good idea, we will start using it. But then they start losing trust, and it's a controversial topic. Why do we lose trust? Half of it is a media thing, half of it is the way we perceive those stuff. There have been news since 2018, right? Aadhaar breach, Aadhaar breach, Aadhaar breach. Did CIDR ever got breached, Sanjay? Not that we know of, right? But the point is, the way it was presented into the media, oh, Aadhaar has been hacked. Why? Because some government entity somewhere in some state was collecting Aadhaar information for some of the data, and they kept it into an open S3 bucket. Now, people who created it put a lot of brain behind it and how it cannot be breached into, but some utilization aspect brought you to a stage where the media headline says Aadhaar breached. The COVID data breach. Was it breach or was it scraping of content online? People don't know, but yeah, breach, and breaches do happen. That's not only from the government data, even from the individual your and mine data. I'm sure a lot of people would be knowing about this particular website, and if you don't, take a photograph, go home, try it out. A collection of more than 12.5 billion email addresses which have been breached, including passwords of most of the places. We have been hearing that, okay, password breaking, let's make the encryption which is used for password breaking quantum proof, right? Quantum safe encryption methodology so that nobody would be able to break it. Hang on, the attackers are not even breaking it. The attackers are just copy pasting it from a dump and using. So your idea of, 8-character password is easy to break in, and 14-character password will take 10 years, 12 years, 100 years to break in. Forget that. Even a 72-character password, all it takes is a right-click copy, right-click paste. So people don't break password these days. Attackers don't break password these days. And that's what the reality where we are living in. Privacy do matters, yes. And very rightly pointed out, Debayan, it's not the problem of data protection. It is the problem of data collection. Not that I'm a very big fan of Snowden himself, but yes, he showed the world that the kind of data collection which we are doing is one of the biggest culprit. And we may have a strongest mechanism, seismic zone proof, data center with everything protected. And we were having conversation during lunch. A very well-known critical infrastructure organization in the country. A friend of mine just walked into it asking for a register. On the second page of the register were the written passwords. Now, think of it. How much energy are you putting into securing that, and what's the reality? Where do we actually live? That's where we are, and which get connected to your social media. The place where the information, misinformation and disinformation, all of that is flooded so much that you need another level of AI to actually start identifying the right versus wrong. Plus, all the AI and algorithmic biases we have been hearing about, a lot of good conversations happening around that. And that's where the whole privacy thing rolls in. We spoke about our favorite Google collecting all the data, and they know about us, but we still use them, right? Oh, that much amount of data which they collected from me is okay, because that's making my life easy. I am happy to give my geolocation, because then using that, I know how much traffic is on the road and I can travel. But then, as we heard this keyword a lot many times in last few years, flatten the curve. The curve should not go beyond the line of care. In our world, security and privacy world, the data collection curve should not go beyond the creepiness. The line of creepiness should not be crossed. And that's what one of the important aspects is. Thankfully, government is working on it. A lot of people are working on it, brought something called as the DPDP, and everybody has spoken about it, that okay, that's very well needed. Is it required? Check. Yes, it is required. Is it timely? A lot may argue that, okay, yeah, it's a little late and we should have had it early. When GDPR can come early, why couldn't have we created something of that very early? Is it efficient? Is it effective by now? The time will tell how much do we, or how much teeth and nail do we provide to that act to work on something. Is the coverage enough? And that's where a lot of people are actually worried that coverage is not enough, because a lot of government entities are outside of the purview of it. And that's where the threat actor attacks, that's where the threat actors start looking at the aspect of the whole data stealing and data copying. We have to worry about the attacker, which everybody happily say it as a hacker. But beyond that, we are worried about the own government looking creepily into your data. Or people have their belief that, okay, this is harmful for me. And we had a very lively discussion yesterday as well around that topic, that, okay, how much trust do we put in our society, in our government, our governance, that they will not use this data, which is now has a primary key called as Aadhaar number and all the keys in different databases connecting together, right? In that way, we are also worried about the hostile nation state, but that's one excuse everybody also uses when a large data breach has happened. Even if the password was passwd at 123, when something goes wrong, they say, oh, it was a sophisticated nation state attacker and that's why we lost the data. Because that's where you say that, okay, the other party has unlimited amount of money to attack you. We will discuss something about the tech journey, because that has happened in last so many years. We started from the password on the time sharing systems in 1961. And from there, we have moved over to a lot of variety of stuff like passkeys and the password manager and multi-factor authentication, and multi-factor authentication becoming so easy, risk-based authentication. A lot of math and science goes behind it, but for the end user, it is still the easiest method they can use to opt in. Where are we in the real world use cases? The real world is still not ready to accept that, okay, password manager is something which I can use to be actually safe. People say, oh, what if the password manager is breached? What if my data is leaked out from there? Without knowing the fact that, yes, you can have an offline password manager as well. You can have a completely disjoint password manager as well. Oh no, but that's too much of hassle for me to do, and what should I do, and why should I do? It's only 10 password which I need to remember, and then I add one number in front of everything, and my password for other accounts are created. We're talking about high-end systems to break passwords? No, we don't need them. QR codes have been one of the very interesting aspects. Suddenly the societal trust on QR code have gone way too high. And not only with the payment system during the COVID times, the restaurant menus are available on QR code only these days. And you have to request that please give me a paper menu, because most of these restaurant menus are like you have to scan the QR code, it will prompt a WhatsApp message, you have to send hi, and you will get a PDF as an attachment to the WhatsApp message. What you got is a WhatsApp message, what you got is the menu, what they got is your name, your number, and a tick mark that this particular user has come into this place, ate something, I know what he ate, and what his choices are. Now where is the creepiness? Now where is the sharing of data? And by the way, this will not come under DPDP because you have deliberately shared this as per the Act. What can be done? What can be done is, and what's needed is education and awareness. A lot of civil societies are coming up and this should happen, that should happen, what Aadhaar should do, what India's tax should do, where the ethics of AI should come in. Where is that coming from? That's coming from the knowledge, the awareness, the education these people have got. At least they've understood the risk. And that's why they can question. And that's what we want. We are not saying that, oh, we don't want oppositions. We want those oppositions so that society can keep a check on itself and walk towards a better path which is helpful and at the same time safe for everyone. And in which these controls come a long way from users' experiences as well. What you face, then you report, you crib about it, you cry about it, and then changes comes. Like, I take one quick example for this. People jumped onto the bandwagon of QR code-based payment and UPI-based payment, where majority of the public who were using it did not know the difference between debit and credit. So the message on the screen would say the amount would be debited, amount would be credited. And they were not aware what's happening, whether the money is coming into my account or going from my account. From there, the user experience has gone up to a level where now the mobile app says, you are sending money, you are receiving money. That's where we have reached. And a lot of awareness has happened on that side. Like, people have gone through all those frauds where someone would say, oh, you need an extra software on your phone so that we can help you. A lot of fraud happened from that using payment gateway. Thankfully, the payment apps have started saying that, oh, I can see your system. You have given permissions to an application which could be monitoring your activity. This is not safe. And this has to come from the corporate itself. Tell people about the issues. And that's how you can start fixing it. Including one of the one which I recently saw in Paytm, I think. It says, while you're on a call and still doing a payment, it says you are on a call right now. Be careful. It could be a fraud call, or if you're having a call with someone and while doing payment, your attention span on this activity, the payment activity is low. So you may cause a mistake. Now this is trust, this is digital, this is society. That lingo used is more important for people to actually build the real trust. What is the future of the digital trust? A very, very long way to go. But what can be done? It's always a good time to contribute and bring change. Shailesh, that one crib hour of the whole month can be brought out and used into something good for the people. People call it as a corporate social responsibility. I call it as a personal social responsibility. That's what I have been doing from last many years. I have trained more than 2,000 students and their parents on cyber safe behavior online, cyber safety, cyber safe parenting, so to say. And then the second segment, I personally, on my personal social responsibility, I talk to a lot of aged people because kids have left them here and gone to America to learn more and earn more while they are stuck here that, okay, should I do the payment from my phone or not? So I've been doing a lot of sessions with them, and as Akshay spoke about in the beginning about the book, that's the book which you can check out. It was not a work of COVID. It was released just at the beginning of the COVID. So people said, oh, you used your COVID time very well. No, it was a lot of work behind that. And the reason was a lot of people used to pick up the phone and talk to me, "Arey, mera aisa ho gaya, kya karu? Hey, what should I do with my phone? What should I do with my email?" I said, let me dump all the answer into one exercise book, one workbook, which people can follow. The book is available on this site, and that's an interesting site which I have created. You can try it out right now on your cell phones. Go to this site called as infobleed.com, and you would realize the browser which you use to see this site, how much information about you this browser is already leaking, the bleeding of the information. That's needed for people to actually know what's risking them and be safe from there. So what are the action items? Just 3. Learn, onboard yourself, and educate others so that we can be on a safe digital society together. Thank you.
Right. Thanks, Rohit. That also gives us a perfect segue into opening up this for a larger discussion. Maybe I'll start with one point that Rohit mentioned on the data protection, the digital personal data protection bill. I'd like to hear maybe Shailesh and Debayan's thoughts also on, what do you feel about the transparency and privacy issues in the bill, because we have started talking about these issues.
The data protection bill should actually be called Right to Deny Information Bill. That is the impact it has. If they had said they are amending the Right to Information Act, citizens would have protested. They put it as data protection, and most people don't know what the hell is happening. The truth is, the scope of exemptions has been widened tremendously in the name of privacy. And what constitutes private information that cannot be parted with should arise from the Constitution. Article 19(2) gives you a limited scope. Unfortunately, that is not being followed by the privacy people, and today everything is becoming private. Anything that somebody wants to retain confidentially, he says this is private. I think there should be some proper norms. And the Puttaswamy judgment, with due respect, 550 pages plus, I think it is. But you read the whole judgment, you cannot figure out what you would call privacy. There are various theories, various philosophies. And the Supreme Court in 4 cases says, what is privacy will develop on a case-to-case basis. Should citizens and public information officers go to the Supreme Court every time they have a problem about whether it's privacy or not? I think we are mixing up the debate very much, but this will need a much longer intervention.
Sure, and yeah, I agree. The judgment is not the right place for that. Then we need legislation for that, proper. With regard to the specific bill that you're talking about, it was very much, what's the thing? That privacy is not us keeping our details secret from the government, but the other way around. And the problems are the sheer number of exemptions, right? So it says that, oh, nobody is allowed to do this, and if anyone does this, here are all the government is exempt, right? So I think there was there's a lot of work that needs to happen on that sphere. I'll also bring up, when bills like this come out or rules like this come out, one of the main issues of trust is, when do I trust you, right? One is, I have built up a long-term relationship with you somehow, and I know that past actions you've taken have not harmed me, right? Or you've done good by me. And that is how one builds up trust over time, right? So your capacity to harm me, the probability of damage should you become a threat actor, shall we say, right? That also plays into the whole story. And given that a lot of our discussions are about governments doing bad things, which they have, right? We can come up with good protocols, and sometimes that can truly help. Technology can obviate items of corruption in many, many ways, right? The famous example, Raghuram Rajan brought that up, train tickets. Sometimes there used to be quite a bit of corruption in getting the train ticket. And then they put the monitor up there that said this many tickets left in this train, right? And now you can book online, and an entire area of corruption has gone away because of the introduction of certain types of technology. That can happen, but more often than not, when the technology itself is launched, look at the US baking in its own backdoor into A51 and A52 when cell phones were launched. Look at the accusations against Huawei, right? Look at what's going on right now. We are hearing this tiff between India and Canada, right? We are being told, oh, we know bad things because we intercepted the communications. The implication is we were listening in on the Indian officials, right? How did that happen? So if even high-level government officials can't trust their own communication system, how am I going to trust mine? So a lot of work needs to be done to build up that trust. This bill does not get us there.
Rohit, you want to also say something?
See, one thing is very easy to do a government bashing, and that's a favorite pastime of the country. We do that. But at the same time, we have to understand one aspect, and which is the key, but a lot get built up around that. The key was, national security. Anything which is related to national security should be exempted, and we should be working on that. And the privacy comes after national security. The national security always supersedes the privacy. But then a lot of people start building their personal interest around that. But can I use the same thing in my government department in the name of national security, but can do a lot? And that's where the exemptions are hurting us. We should not be giving that much free hand. And at the same time, at least some step have been taken. Let's see how the whole implementation comes in. I heard hirings are done by now, so let's see how we go towards the reality of the aspect.
Yeah, from implementation perspective, we have very poor implementation of acts, and I would see the Data Protection Act mandates. One or two things I will elucidate there where there are challenges. For example, the Data Protection Act mandates that as an intermediary, you need, as a data principal, you need to mandate a data, I think, ombudsman or something on every site, every platform. A similar requirement was put up by IT Act, and it was mandated, even government sites will need to put up that. A grievance redressal officer was required to be nominated with the phone number and the email ID to be put up on government sites as well, and it's not there. IT Act is being revised now, and it's not been there since ages, decades. That has not happened. So now look at startups like us. Probably we'll have 30 odd people. How many grievance redressor officers and data protection officers and independent governing board members, etc., are we supposed to put up? So the challenges, is, and I say this pretty often when I say about company law also, I think when they make laws, they go overboard in imagination. And none of the secretaries can actually live up and do the job themselves. So you can't run a company. I can challenge any secretary, run a company exactly as per company law. You will not be able to run the company as per law. So we are basically creating systems which will default, essentially. There lies, the implementation challenge.
I'll just take a quick connection of what Debayan and Manish has said. One system is the number plate recognition system, which will put you a penalty. The other system is grievance redressal system. You should have this information. I'll give a quick anecdote of what happened to me. I was driving in Orissa on a highway and around 76 kilometer speed, and I got a ticket. When I looked at the ticket, it says 7,000 rupees. I said, why? When I went in detail, it says driver name not available, license number not available, car speed 76 kilometer. But the system says because the driving license is not available, there's an extra 5,000 rupees penalty. Okay, I caught hold of a senior police officer there in the network. he gave me an email address of the RTO office because the phone number is not visible online. There's only one phone number which doesn't work. It says the number is out of service, only one landline number. The e-challan portal where you can file a grievance, the submit button does not work. So I have a video recording of that as well, which I sent. I sent to this RTO, the RTO email address is at yahoo.com. I've sent them the email. Every Monday morning I send them a reminder. So I have sent reminder number 19 and I have not heard back from them ever. And that's the grievance redressal. That's where the availability of phone number and a Yahoo email address. So that's the reality in which we are living right now.
Yeah, thanks. I think this actually shows how interesting this issue, important and diverse this issue is. Among 4 panelists, we have 4 different views on the same question, right? So yeah, we can take it up maybe outside these venues as well. Maybe at this time, maybe I can ask if there are others in the audience who would like to either weigh in on what people have said, or do you have some questions for the speakers? Yes?
Hi. I mean, it's a very simple question. I think I would get 4 different answers again. In terms of individual, trade-off of privacy versus utility, how do you see Indian society? Because Indian society is heterogeneous as heterogeneous as it gets. Where do we put our societal trade-off in terms of utility and privacy?
Sure, I can give it a try. So you're right, it's very heterogeneous. I was joking with some of the others earlier today that my students aren't angry the NSA is spying on them. My students are angry they didn't hit like. You know, we live in an era of massive oversharing, right? The attention economy, as it's called, and it's not advertise attention. We want attention. Everyone look at me. That's the scenario, and so we are constantly putting ourselves out there, and very many Indians do not care. That is the unfortunate fact. But I will tell you, they only care until you complete the sentence. So usually they say, oh, I have nothing to hide. That's the usual thing. But if you complete the sentence, nothing to hide from whom? Right? What are people trying to hide from whom? You know, let's say someone wants to hide their sexual preference, or they want to hide their interest in a religion they're thinking of converting to, or they want to hide something else, right? Suddenly, the thing is, as long as you talk about it in general terms, right? Do you think privacy is important to you? Trade-off between privacy utility. People are very gung-ho, who cares, I have nothing to... The moment you bring it into specific terms, specific examples from their lives, things, then suddenly their answer completely changes, right? So I'll go back to something that was echoed multiple times, this concept of education. I'll use a different term. I'll say background awareness. So the example I like to use in this scenario is that of health, right? If your hand gets cut by a rusted nail, you know what you have to do. Why? Because we have background awareness of healthcare. This has been built up over generations and generations. You went to school, you were told these things, you saw it on TV. There were 50 other things that informed you. And that is not going to happen magically and suddenly. We need to build it up over time.
Yeah, to some extent, I think there is pari passu equivalence between Indian society and even advanced nation society. So Google did not originate here, and it originated Google, Facebook, etc. The typical do no evil guys originated, there, where these concerns were more heightened, and they built their business models, successfully there first, before coming here. So I think the trade-off was very well established in advanced nations first before coming to India. As a country, we are struggling for some basic things. And if you can provide, given that you don't away some really private, stuff, I think if you can provide some convenience, some succor to their daily lives, anything that can help them achieve their ends meet, or things like that, I think the trade-off goes in favor of the other benefits they get in the as against privacy.
I'd like to put 2 points before this audience. One, in Hindi, Gujarati and Marathi, which are languages that I know reasonably well, the other Indian languages I am not familiar with, there is no real word for privacy. If you think the way privacy was used in the context of digital, it was more an equivalence for confidential. Confidential is very arbitrary. Privacy has certain connotations. So I'd just like to put it before all of you. Consider this, we were not so private, or privacy was not a concept that ruled very much. And the other point I'd like to put up with respect to right to information is, government has no right to invade my privacy routinely. If there is information that is routinely collected by government from me, and I give it willingly to the government, then it should be open to any citizen in right to information.
Yeah, thanks for that. Are there other questions? Yes, this question there.
Okay, so my question to all panelists is, okay, at the end of this, can you articulate, for example, one project that Trust Lab should do and is sort of within reach of Trust Lab that seems important because nobody else is doing it and Trust Lab could do it, given all of the conversation today?
All right, so maybe we'll make that the final question because I've just been told that we are running out of time. So this is also a nice question to end with, and I wanted to also bring this up. Thanks a lot. So could we go through all of you and each person?
I would submit, Trust Lab decides to cut down its paper and file requirements by 90%, and also tries to persuade IIT to do the same.
So I'll make a joke about the IIT thing. I strongly believe change begins at home. If you think that trust is important, step 0 should be making sure you have trustworthy systems running here. And I've seen many people, including a small joke I also made, talking about how much information is collected about us throughout our time here itself, and whether I can trust who's getting through the gate or not. All sorts of class issues regarding that have been discussed. I'd say try and solve that first. Second, I think having some clear mathematical definitions of trust in certain restricted scenarios that synchronize well with the laws of the land is really important, because we have loads of clever people building incredibly good protocols based on assumptions and scenarios that are in many cases based on Western laws, and many cases based on no laws, based on whatever seems like a good topic to research, right? So if we could have a good, here are a set of rules, theorems, if your protocol satisfies this, it will almost certainly satisfy Indian laws in some way, shape or form, sort of building in that conception, understanding what we mean by trust. That would be a fantastic set of projects.
Do you think there exists such a set?
I'm very optimistic.
Yeah, my ask will be very, very specific. So we, for startups like us, where we have a huge undertaking going to customers, we are handling customer money, and there is no regulatory protection or enablement. I think we need, independent organizations which can set up a code, a guideline that we can adhere to. So our digital assets can adhere to. That I can say that I'm happy to be audited, but there is something that they have created which has a very large ecosystem of brilliant minds, and we can simply go and attest to that and be audited on that. that is something very specific that you can do for us to move forward in a way that citizens can trust us, and trust can be created. So I'm talking governance, so help us with governance. All the brilliant minds that are there, we may not be able to accumulate all of that, and that may not be trusted. so Trust Lab will be trusted, and we can trust the Trust Lab. Citizens can trust the Trust Lab. So something like that will help. If the government is not giving a code, if the regulator is not giving a code, in the US this was done when FINRA, a body called FINRA was established. So I don't know how many of you know that in the US, the Securities and Exchange Commission does not specify rules about investor protection guidelines. It is done by a self-regulated body called FINRA. And therefore, so today the challenges that bodies like us face is, I don't have the, Aadhaar-based KYC or central KYC access, all of these places, access denied. You want to do good things, but you cannot do that because you are not regulated. So it is digital, kind of apartheid. I want to do things, but it's a lot more harder for me to do. So I would request, you to consider creating things that we all cannot be working on our own. I mean, there has to be some central bodies, organization that we all can trust in. And I think Trust Lab, by the very name, kind of epitomizes that.
So there are a lot of things which can be done, outreaches and other stuff, and putting up the right recommendations from the industry side to the government side. But which is already covered. So I will come to a more practical request or more practical suggestion that can be carried out, Mukul, Manoj, and Shridhar. When we get a lot of students as interns, can we look at creation of smaller open source kind of a projects which is helping the human versus security bridging? Something like a browser extension which can people use to report a phishing somewhere, or which can actually tell people that, okay, the site you're trying to visit is a phishing site, be safe. This is very simple, and it's actually doable by students coming on for internship kind of projects. These kind of smaller activities. So a lot of people get fraud call from across the border. Smaller mobile apps kind of stuff in the open source market, which says the moment there is a phone call coming, all it does is flashes a national flag that, okay, this is a call from India versus this is call from which country. Those kind of things will make the high-end tech usable and easy for Aam Janta, and which is where the gap is visible, and that's where the outreaches, the application, all of these will help, and that could be one of the tactical suggestion which I could provide. Thanks.
Can I support you? Sure. I think what I followed, I would like to support him. Alongside my own proposition. What I was following through was there are research grants being given by Trust Lab. I think instead of very high profile research grants, which IIT can probably take care of from its own budget, the Trust Lab research grants should be towards more immediate use cases that we can cover, which kind of starts building the trust gap immediately. The quantum safe can wait a little bit more, but the spurious calls are happening today, and we need to plug them immediately. These are very small use cases, and I think you can do wonderful job by purposing research, into applications.
All right. I think we will have to end the session here. Thanks a lot for this really invigorating session. Thanks to all our panelists, thanks to the audience, and thanks to Trust Lab for giving us this opportunity. Thanks.
So thank you all for joining for this informative session. Now I would like Mr. Shridhar Shukla to join me on the stage and felicitate our guests.
So thank you, Mr. Shailesh. Oh, sorry, Mr. Debayan, sorry. Mr. Manish Kumar. and Mr. Rohit. We also thank our moderator, Professor Akshay. Yeah. So it's time for a short break. We will meet in 15 minutes. Please head to the foyer outside for grabbing a cup of tea or coffee. Thank you. So the tea is available on the ground floor.
So welcome back, everyone. Hope you have enjoyed your tea. So we would like to invite Professor Varsha Apte, head of the Computer Science Department, to come up on the stage and initiate the countdown for the commencement of the national edition of CTF competition.
It's done?
Click.
Click where? Just click anywhere? Yeah. Okay, I'm doing this very, very important job here. Please, I hope I don't do it wrong. Seven, 5, 4, 3, 2, 1. Okay.
Thank you, Professor Varsha. Now we will move on to our next panel session.
Our final session discussion will focus on synergy amongst IITB centers. This session will shed light on the collaborative efforts among various IITB centers, synergizing with IITB Trust Lab to create an impactful innovation in research, technology, and policy development. We have with us the IPCs of different centers. Manish Hanawal from Technocraft Center for Applied Artificial Intelligence, Shishir Jha from Ashank Desai Center for Policy Studies, D. Manjunath from the Center of Machine Intelligence and Data Science, C-Minds, Ganesh Ramakrishnan from the Koita Center for Digital Health, KCDH. So we would like to invite you on the stage. This session will be moderated by the founding donor of IITB Trust Lab, Dr. Shridhar Shukla. We request Shridhar Shukla and other panelists to join us on stage. Dr. Shridhar Shukla experiences span a broad spectrum ranging from research and academia to technology and development, corporate leadership, and entrepreneurship. He is a co-founder of K-Point Technologies, a company incubated at GS Lab, and also co-founded by him. K-Point offers a SaaS video enhancement platform for business, and GS Lab offers software product engineering services. After recently completing his corporate career, Shridhar now spends his time on the two areas, digital trust technology and bringing teacher-centric back in schools, which he believes are fundamental to the social and national well-being. Yeah, over to you, sir.
Thank you and good evening all. I understand we are a little short of time this evening, so we have cut down the amount of time we have available for this panel, but we will still get the gist of it done. thanks to the hard work that the Dean ICR office and DRF does, IIT Bombay now has a number of centers and very purpose-focused entities such as the Trust Lab. So our idea was to talk about how they can work together and instead of operating as lone wolf, operate like a pack of wolves to achieve bigger impact. So I'm delighted to have Professor Shishir Jha, Ashank Desai Center for Policy Studies. He's very actively engaged in analyzing and theorizing various aspects of digital economy, particularly policy-relevant issues. And he's a PhD in political science from Syracuse University. Thank you for being here, Shishir. We have Professor Manjunath, Professor in Charge, Center for Machine Intelligence and Data Science. Professor Manjunath is a PhD from RPI and has had appointments at University of Delaware and Computer Science Department of University of Toronto. And he's now with the Department of Electrical Engineering. We have Professor Ganesh Ramakrishnan of Koita Center for Digital Health. He's currently serving as an institute chair professor at the Department of Computer Science. His focus is AI/ML, very passionate about it, and wants to boost the AI research and ecosystem for India and works very closely with startups through mentoring and collaborations. As I said, he's professor in charge of the Koita Center for Digital Health. And we have Captain Kapoor, Chief Operating Officer of Technocraft Center for Applied Artificial Intelligence, with 20 plus years in Indian Navy and strong specialization in electrical and electronics, AI, machine learning, automation, and data analytics with the US Navy, degrees from Naval College of Engineering and MSc in Artificial Intelligence from University of Southampton, UK. We have one vertical center, which is the Digital Health Center represented by Ganesh. We have two horizontal centers focused on AI, and we also have a very horizontal center focused on policy. And as you've been hearing throughout this workshop, Trust Lab is also a very horizontal area because it is relevant to many of the areas of technology and work that we have. So what we thought would work very well is each of the panelists can talk, first of all, about their centers, so all of you have an idea of what the center does, and then say what they want Trust Lab to do for them and what they would like to collaborate with Trust Lab. After all, at IIT Bombay, one of the most precious resources is the faculty time, then it's also the student time, and all of the logistics related work that we need to do. And so anything that you can suggest by way of achieving efficiencies by working together is game. So over to you. We'll start with you, Shishir.
Yeah, good afternoon. Thank you, Shridhar. And thank you, Trust Lab, for putting together this panel. So just a few things about the Ashank Desai Center for Policy Studies. So the Policy Center is now 6 years old. It is, in a way, running like a department if you want to compare across departments, etc. So for instance, we have a full-fledged master's and PhD programs, and faculty with about 8 faculty right now. So this is actually a unique place because having a policy center within an institutional context like IIT at least promises many interesting conversations. Some of these conversations are not easy because people refuse to have conversations, but not easy because of the kinds of, kinds of disciplinary backgrounds that we come with, and how does one bridge those divides. That's the interesting part where, because of my own interest in the whole digital economy, that's the kind of bridge I'd like to be able to create with the Trust Lab. So this is work in progress, and I'm excited. So let me move to, is that, we should move out to other, yeah, okay. So one of the questions that was sort of asked of us is, for instance, how does one think about responsible behavior for enhancing trustworthiness, right? How would, say, a policy center at IIT Bombay, how would it think about this issue of, for instance, as I said, responsible behavior and enhancing of trustworthiness? So a few remarks, right? For instance, as someone who comes at this field from political science background, political economy, it's very interesting that the so-called digital economy, if you want to use that word broadly speaking, the digital economy is an economy and a structure that has had an unprecedented growth, right? If you compare it, and I'll come to the point in a few minutes. It's an unprecedented growth compared to any other industry the last 300 to 400 years, right? In the sense of the speed and scale at which the digitization process has happened across the planet. So there are some interesting implications that arise of it. One reason why this has happened, among many, one reason is that the property of the digital economy is, particularly the property of, one would say, non-rivalrousness, right? That really creates a decisive rupture with the older so-called brick and mortar economy. So there is, in other words, a sharp discontinuity, right, with the older brick and mortar models, right? If you look at any industry, right, entertainment is perhaps the one that comes to your mind most quickly, but say whether it's music or films, publishing, automobiles, there's more software in it, right? Finance, healthcare, disruption is almost the rule with the digital disruption. And the stakes are staggering, right? That's what perhaps we've been discussing also between yesterday and today. So given all the staggering nature of this disruption, how can a center like the Ashank Desai Center for Policy Studies and its engagement with Trust Lab, how can we really discuss issues like responsible behavior or trustworthiness, right? So towards that, I'll just have a few comments and then, we'll move on. So one suggestion, which we also discussed quite a bit within other aspects of CPS, is that we've just not had in India, for instance, we've not had an active culture of the government or institutions, right, of commissioning rigorous research work that must be placed in the public domain, right? So policy making, if you care to look at it sort of, post-independence, if you look at it a bit more closely, yes, there are several instances of policy success, but more than the instances of policy success are policy failures, right? And how does one learn from several instances of policy failures, right? Given a new economy that's on the horizon, not just on the horizon, right? It's in fact, we're embracing it with great vigor, right? So in the face of such rapid changes and, given the scale and speed of these changes, right, how does policy, sort of respond, right? And here, because the policy center cannot get into advocacy because we are obviously located in an academic institution, one thought that we have, which we, as I said, constantly discuss, is that how can we put more and more of our work, research work, right, commissioned work, in fact, into public domain. So if in a typical way, for instance, in many policy contexts, you either have a private body which kind of gives inputs to the government. If there is an invitation for to be able to, if the government puts an act together, or is trying to put a new act together, it is requesting for information from the public at large, but those windows are very small, like 2 weeks to 3 weeks. The culture which I'm sort of suggesting here is that perhaps 6 months, a year earlier, right? You get 10 to 12 scholars across the country who actually take a very close, meticulous look at what does it take to be able to put a policy like this together, right? Whatever is the domain. Put all of those thoughts in the public domain, right? Let there be more intense engagement and discussion. A place like IIT Bombay is perhaps very apt to do that, right? So this is, one possibility where perhaps centers like, for instance, ADCPS along with Trust Lab can collaborate to be able to do that, right? So that kind of a active academic culture is something that's missing, and it's something that we would like to see being changed. Right.
Sorry, we are really short of time, so I'm just tracking the clock. You could say what your center does and what you want from
so I'm going to say a few words about the Center for Machine Intelligence and Data Science. It's about a 4-year-old center. My view of that is it's an omnibus center where faculty across the institute who have any interest in data science or who use models that are derived from who use AI-derived models are associated with the center. So at this time, we have about 80 faculty from across the campus who are associated with the center. We are looking for core faculty. We have interviewed several now, so we expect to ramp up to capacity very, very soon. In terms of what kind of synergies the AI and data science faculty on the campus can have with the Trust Lab, I think I'll probably be stating the obvious. There are two typical, I would treat Trust Lab's two main objectives as security and privacy. In the matter of security, the AI techniques become very obvious if you want to look at patterns of how attacks happen or any of the other various problems in security that happen. So AI is a natural tool that one can use to do that. So synergy between people who do data science and security research from Trust Lab that's a natural place for synergy. The other vertical or other aspect of research that Trust Lab would probably be doing is privacy. And again, the data science by definition wants to handle a large amount of data. So given that addressing privacy concerns with the kind of data that we have would be a natural synergy between the two centers. I just want to plug one aspect of C-Minds. We have one initiative in which what we do is we try to bring up what we call a grand challenge project, which we want to make. It is not necessarily driven with a strong research or publication agenda, but uses cutting edge to deliver something or showcase something to the public. So one of the immediate projects that we have is something that we call the Public Data Project, where we collect data that is available publicly, which is not machine readable or usable in a usable format. And that is now sort of collated, cleaned up, and made available to the public for use. And the motivation for this was that if you look at many of the data science programs across the country, the data that they use is not always, or almost never from India. So they don't have the natural questions that one should ask when data is available about our own society, our own country, our own neighborhood, doesn't come naturally to many of these people. So the objective of that particular project was to be able to provide data so that such questions can be asked. And one immediate project that I can offer or suggest to Trust Lab is that recently I had some occasion to collect data from across the various IITs for some particular question that I had interest in. And it turns out that IIT Bombay has probably the most detailed, granular data about students, both in terms of the volume and the cleanliness of the data, and also historical. It has about at least 20-25 years worth of data of the entire student population that has passed through IIT Bombay. Now this is a gold mine to understand what has IIT Bombay done in terms of demographics. So one obvious thing that I would like to ask Trust Lab is, would you be interested in taking this up and providing a anonymized version to the public so that they can do whatever study on that? That's one question that one request that I would have for Trust Lab.
I'll make a quick presentation. So I'll speak very briefly and let the slides and a handful of these brochures do the rest of the talking. Can I have the slides, please? So the Koita Center for Digital Health was founded 2 years back, thanks to generous donation from Mr. Rizwan Koita and his wife Rekha Koita, who are our distinguished alumni. As first of its kind center in India, bringing synergy between hospitals, the healthcare ecosystems, and also government with the engineers, which we are boasting about most of the time. Can I move to the next slide? We also work closely with the Ayushman Bharat Digital Mission, which has provided a sandbox environment for hospitals across the country to bring their data. Now, what is Koita Center's unique USP, which actually could be leveraged by Trust Lab, and we would also like to benefit from the research at Trust Lab, is the large amount of data that we have potentially created highways for with the hospitals and the healthcare ecosystem in the country need to be anonymized before researching. Now, certainly there's a certain degree of de-identification that happens when we engage in our R&D programs with hospitals. We have also a student, very rich crop of dual degree students in interdisciplinary dual degree program and PhD program. Can these students engage in a joint program with Trust Lab where the de-identification of the data can help cross-pollinate across hospitals? I think to me that's a very important need. And we just had one round of interns sponsored by Trust Lab, and they got a paper out in the area of federated learning. This is at the Koita Center for Digital Health. Go to the next slide. Yeah, so the 6 broad areas that Koita Center focuses on, starting with healthcare applications, and you see these keywords in healthcare applications and data management, federated, right? So federated data management is one part, but the real use of this data is when you do analytics. So how can we do federated learning? Now, federated learning is a broad enough term which includes many other paradigms like split learning, etc. What's the basic idea? You want to learn from data without necessarily even sharing the data, right? Think of sharing meta information about the data through what we call gradients, right? And a level ahead is when you don't even federate, right? Federation requires some server to arbitrate. But imagine it just happening in a very peer-to-peer manner, right? Many of these peer-to-peer networks, imagine using them for actual learning. The other very important area, which I feel this also holds a potential for cross-pollination across Trust and KCDH, is the area of computational biology and bioinformatics, which again we are very heavily invested into. Think of the genotype as a signature for a large population, and especially when we look at diseases which have a huge backlog to actually factor in the modeling, right? Cervical cancer, for example. Now, it's best captured through the abstraction of genotype information. How do you ensure that you get that right level of abstraction through genotype? Or you could also look at multiomics while not revealing information about the individual. So privacy and security both factor in there. In fact, the public health is the last vertical. We actually have a national disease modeling consortium. This is beyond the engagement with dozens of other hospitals. We have a disease modeling consortium at national level chaired by the health secretary himself, and DBT secretary and DG ICMR are co-chairs. So as you can see, we also have actually built our channels into the bureaucracy, into the administration at the national level. And one of the big challenges is modeling diseases, right? And especially modeling diseases across different regions. Ultimately, state is a health subject. So how do you get the data of Maharashtra that is used for modeling to be effective and yet distilled when you do modeling for, say, Meghalaya? So maybe you can move to the next slide. So this kind of summarizes the two broad areas which I feel. One, federated learning, where we already have made some start, but I think we should take it a lot more seriously. It's a huge opportunity out there. And there's no way data sharing can be ever mandated. You have to ensure federation and data, privacy preserving computation in the learning space. And the second, as I pointed out, is in the computational biology and bioinformatics, foraying into public health. We can have our students intern at Trust Lab. We could have Trust Lab attract a larger lot of PhD students and master students to KCDH, since we run an academic program. So that's something, again, Trust Lab can benefit from. Thank you very much.
Thank you. Thank you, Ganesh.
Thank you, Shridhar, for introduction, and IIT for giving me this opportunity. I represent the Technocraft Center for Applied Artificial Intelligence. I am appointed as the Chief Operating Officer, and I, on behalf of Professor Manjesh, who's my professor in charge, would like to inform the audience and the panel here the work that TC2I is involved in, and how it is a little different from what the other AI center, which is C-Minds in IIT, is. So, like rightly said by Mr. Shridhar, we are a horizontal thing. We don't have a focus area like any other center. We have done some past research in 5G networks. We have done in image processing using the X-rays. We have done work with the EDRs. There are many other such work that is in the research stage. It has reached certain maturity at some of them. Some of them are still in work in progress and would see the light of day very soon. What synergy I would expect from the Trust Lab is IIT and any other institute of repute is very, very good at research. Now I'll just go back into my 4G mode of retired on 1st of September. So I'll tell the viewpoint that we in the defense of the government felt about institutes or what we felt about the data deficit in the industry. Yes, IITs and institutes of that repute have enough knowledge, enough time, enough resources, but the timelines were something that bothered us. The change of technology was so fast that, and the processes that we also had on our end, these two things did not ever match. And at times, we were more interested in the product rather than the research about it. You give me something right now which I can use rather than use something which will be used to me in 10 years, because 10 years, I don't know what will change, right? We couldn't go directly to the industry because the industry was primarily used very, very open source, tools, libraries, and they were, which were not, built or envisaged keeping the defense requirements in place. So my center, what I, would expect to be doing, rather, we're still in that discussion. I'm just 10 days old. We would like to bridge this gap of the great brains in the research and the speed of execution through a tripartite work centered around the digital trust. Now, why defense is more concerned about the trust is, in the past, if, I don't have the statistical data with me, but I'm sure we, or rather the defense was the first organized, sort of organization which a lot of people acted with and against. All the attacks, starting from the, be it the computer age or before that, were primarily targeted on the defense or the armed forces of that nation. If you go a little ahead, yes, the forces of, the kings and all that. So for many, many years, the defense has had the reason to not trust, or the trust deficit, because the trust was broken again and again. This brings me in, giving a use case to Trust Lab is, if there can be a study which can be taken in the, recent past, or maybe some 10 years, 12 years back, to see what all threats, that the defense or the government or these organizations, faced with India abroad, make some, a framework for that and see where we can, bring that trust in these big organizations before they, look for a deployed product rather than a research product. So that is what synergy I would, expect from Trust Lab. Apart from that, there's another problem of certification. There's a small example that I'll take. My center has built one EDR. So of course, they, before I joined, they had approached one of the armed forces. The first question I'd ask is this product of yours certified? So like it was told to me by my PIC, it was difficult for him to find the right person or the right organization which is government recognized to certify an EDR. EDR itself was supposed to find, the tax and all that. It's supposed to go to the kernel level and find the activities there and report. So it was a big question that, we couldn't answer that time. But yes, over a period of last 1.5 days, I interacted with multiple, people representing various agencies here and institutes here. We got some knowledge, yes, and we have in the last 1.5 days, we've been talking about the awareness, the knowledge and all. And I bet the knowledge that I've gained about, the data and security and the identity is, being 20 years in defense, I never had this clue that these things probably existed. So of course, awareness is there, building the trust is there for these defense forces through some study in the past and having a framework. When I compare, two in a spectrum, one side is you have the social media where everything and anything of anybody you just uploaded, like one of our panelists before this panel discussed about, we are not bothered about kya ja raha hai, kya nahi, jab tak it doesn't affect me. And the second end, we have the defense forces. I'm just taking an example of that. We are so worried about the data because the loss of data is not of loss of your identity or, it is a loss of your national, maybe secrets and some data which is detrimental to our nation. So it's a trade-off between the impact the loss of data has and, the ease of use. Somewhere between is where the trust factor comes in. This is trust deficit. This is, breach of trust, which, in the past, Google and all this that we've been talking about. Somewhere in the center is where the policymakers, the regulators from the government, the trust, builds up. So that is where area we are looking to, we go back to defense and government and say, okay, we have a research thing, you can have trust on us, this is something which we can certify. So that also, it's a loud thought, can your center also be a certifying authority for something like EDR? Can a government, so I don't know what answer would lie, but we can definitely explore whether a center in IIT, which is a government thing, is authorized to certify. Thank you very much.
Question to organizers? Time up? So, we are under severe time pressure today, so I want to thank you, all of you, the panelists, and apologies for cutting down the time significantly. And we will now wait for,
So I thank all the panel members for joining us today and helping us understand how each center can align with IIT Bombay Trust Lab to create meaningful collaborations. So now, I would like to request Mr. Sanjay Jain to come on stage and do the honors and felicitate our panelists. So thank you, Captain Kapoor. Professor Ganesh. Professor Manjunath. Professor Shishir. And we also thank our moderator, Dr. Shukla.
So next up is a keynote speaker from Shafi Goldwasser. We are waiting on Manoj sir, so kindly wait for the call to set up. So we request Professor Manoj Prabhakaran, the principal investigator of the Trust Lab, to come up on the stage and introduce our esteemed keynote speaker, Professor Shafi Goldwasser.
Hi, Shafi is still setting up her screen sharing. Meanwhile, I'll introduce her. So it's our great privilege to have Shafi join us. Should I join? So has she come online?
She hasn't yet.
That's good.
She will be able to hear you.
Yeah. And you could remove the background maybe from her. I don't know. That's okay maybe. Yeah.
Why is it not getting displayed?
Do you think it's... Oh, all those you can do it from there. Okay.
Okay. Let's try to share it now.
Oh.
It says host disabled,
yeah,
participant screen sharing.
Just, can you make her do this?
Yeah.
Did you enable it?
Yes.
Okay. Okay. I think you can see it now, right?
We can, yeah. We are trying to get it on our big screen here.
I'm just going to grab a cup of coffee.
Okay, sure. I'll be introducing you by then. Or you could do it from here and there if that is working.
That machine will have to have a download and setup.
Oh, no, I was saying if that connection works, you can do it from that connection on your machine.
The same connection. Is it?
Oh, I thought we would have tested this.
Okay.
Okay, so while we are still struggling to get it on our big screen, let me introduce Shafi. So Professor Shafi Goldwasser is the director of Simons Institute for the Theory of Computing and is a professor at UC Berkeley, MIT, and Weizmann Institute. Goldwasser holds BS in Applied Mathematics from CMU, 1979, an MS and PhD in CS from UC Berkeley, 1984. And her discoveries include the introduction of probabilistic encryption, interactive zero-knowledge protocols, elliptic curve primality testings, hardness of approximation proofs for combinatorial problems, and combinatorial property testing. So if that didn't make sense, basically, her research has shaped a lot of the modern cryptography as well as modern theoretical computer science. She received the ACM Turing Award in 2012, which is like the Nobel Prize for Computer Science, Gödel Prize twice in 1993 and 2001, the ACM Grace Hopper Award 1996, RSA Award in Mathematics 1998, ACM Athena Award 2008, Franklin Medal 2010, IEEE Floor Award 2011, Simons Foundation Investigator Award, BBVA Foundation Frontiers of Knowledge Award, and L'Oreal UNESCO for Women in Science Award. Professor Goldwasser is a member of the NAS, NAE, AAS, which are all American academies, as well as the Russian and Israeli Academies of Science and London Royal Mathematical Society. She holds honorary degrees from many universities. And it's a great privilege to have her speak for us. It's kind of early in the morning in the East Coast where she is currently, and we should be able to see her online as soon as we are able to get our setup working. And the title of her talk is Constructing and Deconstructing Trust, Employing Cryptographic Recipe in the ML Domain. Okay, I think it's coming up.
Shafi, can you start?
Okay, we should be fine. Please, one more. I think it should be working now.
Okay. Hello, everyone. Hi. Thank you for inviting me. Sorry I cannot be there in person. So the title of my talk today is Constructing and Deconstructing Trust from a point of view of a cryptographer. As Manoj mentioned, I'm director of the Simons Institute at Berkeley, and this is a picture of our collaboration space. I know a lot of you have visited. Some reason doesn't let me. Oh, okay. So if I think as a for a minute as a cryptographer, cryptography has had a huge impact. Is everything okay? I see that you guys are moving there. Can you hear me?
We can hear you, but not very well.
So, can we? Laptop support.
just we have some sort of a setup here which hopefully will work. Yes.
Okay, so I hope that you can hear me. And okay, so let me restart here. So cryptography is kind of a story that is probably unusual in the sense that a lot of things. No, you saw it before, right? Okay, let me try again. Okay, what do you see now? I actually do have animation. How about now? Huh. You understand why? But you're not going to see animation. It's too bad. Is there some way to fix it? You know, if we're already doing this, you know. Okay. I did share screen. So you mean share the desktop? Which? Okay, so what are you saying? What should I do?
And then go to Zoom and say share the window. Hopefully you'll see
I'm not sure. I'm not sure what you're proposing. If you could maybe tell me exactly what to do, because I. Okay. I think I did that already once. Let me try to find where it is. I don't think it worked. Maybe it worked this time, but it didn't work before. Hold on for a second. Yes, I understand. Yeah, that is what I did before. I will try to do it again, see if that makes a difference. Yeah, I understand what you're saying. Hold on for a minute, okay? That. What do you see now?
Yeah. Well, no, we are seeing the editing window, not the.
How about
she just has to start the slideshow. I think she has already started the slideshow.
On my screen, there's a slideshow.
Yeah. That's what. Yeah, okay. But we are not seeing the slideshow. And you had tried sharing the whole screen, right? Desktop.
Yeah, I tried both. All right, listen. Why don't we just do it in, whatever without the, the.
Yeah. Okay.
Without the, it'll be. It's too bad, but whatever. Okay.
Okay. We'll go ahead with that.
Yeah. Let me just try to make that as big as possible. I'm not going to start editing my slides, obviously. All right. Okay. So, where I was at, okay, let me just go for the talk. Hi, everyone. Okay, so what I was going to say is that the crypto story is really a kind of an unusual story, I think, probably in computer science, maybe not in physics, but where you have a clear arc from theory to impact and to use in the real world. And the crypto story really is often people see a bunch of tools: public key encryption, digital signatures, zero knowledge proofs, program obfuscation. These days people talk about blockchains, and each tool is discussed separately. But the truth is that what's going on here is that if you think about the original paper that introduced modern cryptography by Diffie and Hellman, they say there's this amazing development in technology where we have an internet where everybody can communicate with everybody else without ever meeting beforehand, and how can we use it? There are going to be adversaries around, and we would like to use it for secret communication, for transactions, and so forth, which in fact became the case. The issue is that they said we have technology, but we can't trust it because there are adversaries lurking around. And what the crypto story really is from that point on is how to enable us to trust technology, even though adversaries are around. Namely, how can we communicate in privacy even though someone is listening on the line? How can we withdraw from a bank account over the internet, or how can we make purchases over in Amazon when someone else would like to pretend to be us? So we have technology out there, we'd like to use it, but we know someone is trying to steal our identity or listen to our communication. What we need to build is a mechanism where they can use it seamlessly, as if there were no adversaries present. So why, in a minute we'll see why do I want to think of cryptography this way, but before I show you applications for that point of view in the modern world, I want to say that at this point in the lifetime of cryptography, the Diffie-Hellman paper came out in '76, it's now 2023, we really have some kind of almost a recipe or a set of principles for how we build trust when we need to. And it works like this. We define a task, could be communication or working in the cloud environment where we don't trust the cloud. Then we model an adversary. This is the picture of the adversary here. Then we define what kind of security is it good enough for us. So we might not be able to achieve the task perfectly, but there's sort of a good enough definition of security. And then we build a crypto primitive. And what's very important from the point of view of theory is that we have security proofs. So we prove something that looks like this. The primitive is secure according to the definition we made in the presence of the adversary that we modeled. And often we make assumptions. What kind of assumptions? Like factoring is hard, or computing over some hard problem over integer lattices is hard. So that's computational hardness. Sometimes it's not computational hardness, or not only computational hardness, but we think there are several people in the system and not everybody colludes with everyone else because they might have conflicting interests. Or we might make a trusted hardware assumption. But that's the recipe. And we don't always use this recipe just for building a primitive which we claim you can trust, but sometimes it's also for proving that there is no such primitive. So we say, listen, you should actually be distrustful because the definition that you want to achieve is unachievable. Sometimes even those insecurity, impossibility definitions are under assumptions. We're saying, listen, if you could really do this, then something else fails in the system. Okay, so we have a recipe. And now I want to say that this recipe can be used to address machine learning problems and others. But in my talk, I'll focus on machine learning. And why do I want to say that we should have such a recipe and it will be useful in machine learning? Because really there's been problems of distrust in machine learning for a very long time. In fact, it's really even before that. So we don't have that much time, so I won't talk about all of this, but there really has been decades of trust issues in science. It started with the replication in science crisis. In 2016, it was all about the fake news, at least in the American elections. Can we really believe what we see, or is it some avatars created by AI? Then around 2018, all the rave was these prediction systems that will replace bail, will replace policing, like tell the police where to go, will be essentially because of analyzing past data and sending a police car there. What you see on the slide here was that in California there was a bill which was voted, was up on the ballot, whether one should take cash bail, where you have to pay money in order to let people go out on bail, and the judge would rule how much money you need to pay to go out on bail. Of course, that was unfair to people who did not have money. And the proposal was to replace it by a yes-no decision. You can go out on bail or not, and that would be automatically decided. And you would think this is a much better system than cash bail, much fairer system, at least on economic basis, but it was voted down because there was major disbelief in AI prediction tools, saying we don't know, it's unexplainable, it might not be fair. So the issue is distrust. And now in 2023, everybody's talking, should they trust ChatGPT? Should they trust Bard? What does it even mean for an AI system that would be trustworthy? And what you see here in this table is something that I found in the UK regulation, where they advise companies who are going to use, let's say, ChatGPT or other AI tools, that before they use them, they should be very careful to figure out what data was used by the system, what model the system was following, what compute, things which are really beyond the pay grade of a company that just wants to use ChatGPT as a black box. But the reason they're being warned is because they're saying, listen, you might be, by using this AI chat box or ChatGPT, you may run into legal problems because it may contradict privacy rules, copyright rules, and so forth. And probably down the line, there will be rules about using AI explicitly, regardless of whether it violates a privacy or copyright law, and that remains to be seen. But the issue is why people don't, yes? Is there a question? Everything okay? Okay, so the question really is, all right, there is this trust or lack of trust in artificial intelligence. On the other hand, there's huge utility. So the proposal here is to maybe try to figure out how do we use the same cryptographic recipe or set of principles to address this lack of trust, and to get to a situation where we can actually use these platforms without thinking about all these other issues. So if we think about the recipe, now instead of talking about crypto, we'll say, okay, what's the machine learning task? What is the adversary that we are worried about? What is a good enough solution? And let's build a trustworthy solution and prove that it is trustworthy. Namely, it's good enough in the presence of an adversary. So this picture here of a hammer and a nail is because obviously I'm a cryptographer, so everything to a cryptographer looks like a nail or a cryptography task. But bearing that in mind, I will try to convince you during the talk that that's a good set of principles to follow. So how, two key points before I show you several cases of AI problems and adversaries and solutions, and that is that differently from cryptography, AI was not originally designed with an adversary in mind. You know, cryptography, if there's no adversary, there's no need in cryptography. If nobody's listening to your communication, you just communicate. You don't need to build a privacy system. Yet AI systems, they have a lot of payload without thinking about the adversaries. But at the same time, they're very attractive targets. You know, the stakes are high. So if we want to be assured that it's safe to use them and they are composable, adversarial modeling is very important. And when I say adversarial modeling, I mean I don't want to make any assumption on the strategy of the adversary. It might be a worst case adversary coming up with very tricky ways to fool us, but I will make assumptions about the computational limits on the adversary time. All right. So another thing to say is that the way, you know, there's a big difference between learning theory and learning practice, where learning practice is charging ahead. Learning theory, you know, you're modeling things, it's very slow, it's on paper. But this issue about whether there is an adversary around or not applies both in theory and in practice, and whatever definitions we're going to come up with also apply in theory and in practice. So hopefully the methods we can come up with will apply both in theory and practice, and as usual for the time arc that it takes to go from theory to practice, it will take time, because often these theory that we are proposing is slower in practice than what's desirable. Okay, so the way I'm going to go about this, I'm going to look at the machine learning pipeline, where there's collection of data, training of models, verification of models, and then use, and try to see in each one of these stages who are the adversaries that come up. We're going to think about sort of two algorithms, which is the traditional, this is my PowerPoint. It's not going to come up because I'm not doing presentation mode, but there's sort of two algorithms. There's the training algorithm, there's the inference algorithm. Training algorithm takes data from some distribution. I'll think in this talk about the case which is supervised, so there's X is the input, Y is the output. It might be a label, it might be a risk score, it might be a sequence in the context of a large language model. But the goal in general of this training algorithm is to come up with a model, H, sometimes I'll call it an hypothesis, and the goal is that the expected loss that this H makes when it tries on input X, you see over here, H is essentially an inference algorithm, which takes X and applies a Y. We want that the expected loss of H of X with what H says and what the real Y would have been is small. And this training algorithm may really be like a feedback loop. So it doesn't just take X and that's it. It takes some of the X, it sees how it works, it improves, but I don't want to look at the guts of it. And again, when I talk about the inference algorithm H, I want to more generally talk about, it's not H that necessarily has a 0-1 output. It could be a risk score, could be a sequence, could be a distribution over sequences. All right, so let's look at the adversaries. Who are the adversaries that would come up in a training time? There could be lots of adversaries, but for example, you could think of two extreme points, and that is, what if the server itself that's training the algorithm is adversarial? And the kind of adversary I mean here in this particular point is an adversary who wants to learn more about the privacy of the data that's necessary for him than for learning H. So possibly the whole goal is to learn a good H. That doesn't mean that he needs to know all the data points. So I want to come up with a solution where, in spite of the fact that the task is I want to train a good model, but I want to do it in such a way that you can't learn more in the data that the model reveals. Of course, the model could just memorize everything and be a truth table, meaning every X has a Y next to it. But that's not a good model. I'm talking about you've outputted a model, H. It's, let's say, a small model that's supposed to learn some mapping from X to Y, and you want it to be, once you've done that, to have the guarantee that this model does not, whoever trained it did not learn more about the data than H would have revealed anyway. And let's start with an adversary which is honest but curious. Now, because we started late, I cannot do everything I'm going to, so I want to come back and say that another kind of adversary would be where the trainer is fine, but the data owners are adversarial. And maybe some of them are adversarial, not all of them, and they are changing the data in order for later to get a better decision than they would have when they actually, in the use case, in the future. And so these are adversarial data owners, and they might be able to data poison because they have a goal for some eventual goal. So these are the type of adversaries we'd consider, and cryptography can be used in order to address them. So in spite of an adversarial trainer, we can sort of force it to work, but without learning your data. Or in spite of poisoning, you can make it so that you train a robust model, robust enough, as robust it would have been if they didn't poison the data, even if, let's say, a certain fraction of the data owners are poisonous. Okay, so I'll tell you a little bit more about the privacy methods that we use. So because I'm a cryptographer, I'm very well aware that there's lots and lots of techniques out there from traditional cryptography to address this problem. The two techniques that are out there really are, one is using something called fully homomorphic encryption. And the idea here is people never give their data in the clear. They always encrypt their data, encrypt X and maybe Y. both of them. Then there's a way, so this is an encrypt phase. This would have shown up one at a time, but there's an encrypt compute phase where there is a way to run the training algorithm without ever decrypting, using homomorphic encryption, which can be shown secure under something called a learning with errors assumption. That's an assumption that if you give me a system of equations over, let's say, a finite field, but you don't give me the solution to the equation, so you give me a x1 plus b x2 plus c x3, lots of equations like that. You tell me what a, b, and c are, but you don't give me the solution x, and that's the left-hand side of the equation, and you give me the right-hand side of the equation, but a noisy version of it, because otherwise it's just a Gaussian elimination. So this is learning with errors. Even though you give me errors, the problem is try to learn the solution to the equation. Turns out a very hard problem, and we assume it's hard for any adversary, any computationally bounded adversary. And under that assumption, we can build homomorphic encryption. The second assumption that's made here is in the decrypt stage, because as the output of this box will be an encrypted hypothesis. So whoever runs this never really knows anything about the data. Now they want to figure out what H is. Now there are, let's say, shareholders. They hold a share of the decryption key, each one, and each one of them applies some routine some algorithm that's based on their share, at the end of which H comes out. So what we assume here is that the key shareholders don't collude, because if they did collude, they could figure out H, not only H, which they should, but also decrypt individual data items. The other paradigm for doing this is called multi-party computation. In this case, we don't use homomorphic encryption, but we have compute servers. Each one of them gets, you take this X, your X, you split it into two shares. There's a way to do that. And then there's sort of a complex but beautiful method for any algorithm to run the algorithm on shares without actually having to reshare the pieces of X to figure out what X is. So here you're trusting that these compute servers don't collaborate to figure out what inputs X, Y were, but they do run the training algorithm, and at the end they're able to have shares of the output, and they reconstruct it. The point really is, without understanding the mathematics, that also here there are two phases. There's a two-party secure compute phase, and then there's a reconstructant phase. And lo and behold, even though these are very different methods, the assumptions are the same. So here you need something called an oblivious transfer, which again can be implemented using the same assumption that learning with errors is hard. Plus, you're assuming that these compute servers don't collude. So in the previous slide, I had 3 people holding the key. Here, I could have also 3 compute servers. So there are 2 methods out there. People have used both, sometimes a combination. The issue with all this is that it's very beautiful, and on paper works wonderful, and in the inference stage it works well. But in the training stage, there's really a huge challenge of scale, because we're talking about huge amounts of data, huge amounts of compute, if you think about it in LLM. And right now, these theoretical methods don't work in practice. But they do work when the model or the computation that you're trying to do is simpler. So if you look, what I have here is a sort of 3 axes. There's the computation you want to achieve. It could be just a linear function. So you've got a lot of data, x and y, and you want to fit a linear function to it. Or maybe you want to fit a logistic regression function to it. So it's nonlinear, but not too nonlinear. Or maybe it's a neural net, which has 2 layers, maybe it has 10 layers, and then there's a large language model. This is more and more difficult computation, more complex, and right now, what we know how to do is we can get to logistic, but when you get to neural net stage, to be honest, you can have mock cases, but you really, at scale, you still can't do it when the neural net becomes deep. The other axis here are is the assumption. Computational hardness is one assumption, no collusion is another assumption. Hardware, efficient and trusted hardware, is a new assumption, not really new. It's out there. It has a lot of problems, but I think it's a very interesting assumption, because at this point, given that we cannot do, let's say, large language models or very deep neural nets efficiently and at scale, we need to take a closer look at trusted hardware. So I want to show you a case where scalability is a major challenge, and we have been able to make strides, to make progress. And that's the case of genomic analysis. Like you have a lot of patients, let's say, or potential patients. They have markers of whether they had an illness or didn't, and then they have their genome has been sequenced. and you'd like to identify what is a correlation between particular genetic traits or alleles and illnesses such as breast cancer, colon, Crohn's disease, schizophrenia, many other things. It turns out that there are two issues here. One is you need a lot of patients to get signal to figure out the correlations. So you need a lot of data. So scale is a problem. And second, if you use methods like anonymization, which people always think of when they think about trying to protect privacy, it doesn't work here because the data itself is revealing. So if two people are related and their genetic sequences are related, and then one has some public data which identifies it, it immediately identifies the second one as well, to a close approximation. And because this is such an important problem, people have worked on it quite a bit. They have applied both the two-party, multi-party solution and the homomorphic encryption solution. There's been a paper by Bonnie Berger's group at MIT where they did an analysis using multi-party computation. Then there's a paper in Duality, which is, I'm a member of that, using homomorphic encryption. And the papers go back and forth showing, well, these guys claim you cannot do homomorphic encryption, and then we showed you can. An interesting recent work that I've been involved with is instead of doing genomic analysis on a data set that's out there, which is usually how you apply these methods, we went and got real data from a hospital. So this is analysis of oncological data. And we wanted to do privacy-preserving analysis and using homomorphic encryption, but what's called a multi-party homomorphic encryption, where the keys to begin with don't belong to one person, but they belong to many people, where each one of them has a share of the public, each one has a share of the secret decryption key. And what we've shown is a way to do a bunch of operations like mean, median, and standard deviation, survival analysis, logistic integration quite fast. And this was done by some new methods called interactive bootstrapping. It can address things like joint operations. So if the same patient, and you don't know who it is, of course, because his data is encrypted, but the same patient appears in multiple databases which do not collaborate, so they don't want to reveal the data. But you'd like to be able to join information on the same patient that appears in different databases. Okay, so let's go ahead. And I just want to say that, of course, genome is not the only place. People have used multi-party collaboration and homomorphic encryption to detect cyber risk, to measure financial risk. So this is in banks. This is among different companies who want to know what kind of cyber attacks are around, but they don't want to report their own attacks because they want to preserve that. Maybe they're afraid of public scrutiny or whatever. So another thing to mention is that the kind of privacy I talked about was that you could reveal age, but not more than that. Differentially private actually asks something different, and that is, given even if you knew age, you shouldn't tell whether a certain data point was in the training set or not, okay? And the formal definition is here. It took, differentially private, which was originally developed in the context of databases, to machine learning, saying that take a point, and like what I had before was an XY, now it's a ZY, which is and you want to say that for any such point, regardless of whether it was in the train set or not in the train set, the hypothesis is going to, or the model, when you give it a new point, it will give it an output with the same probability, regardless of whether X was in the training data set or not. Of course, it's not exactly identical, but it's not far away from each other by this factor. But you can incorporate this as well. So if you think about what I just described to you with the homomorphic encryption, you could just add differential privacy sort of into the training algorithm and do the encrypted training of the new algorithm, which includes differential privacy in it. And by now, there's a lot of work in differential privacy, because the issue there is they add noise, and the question is how much noise? Does that increase the size of data significantly? There's beautiful work there. Maybe one of the nicest things is this body of work called PATE, where they train many models rather than one. Each one of these, this is all under encryption, say. Each one of these models has a different, let's say, a decision, might have a different decision for the same input, and they sort of build a histogram of these decisions, and then they add noise. So they're adding noise before they output, you know, let's say the output of the model. But the model now is an aggregation of a whole bunch of models. Each one of them might give a different decision. You make a decision on the decisions and then add noise. So there's a nice saving in noise and a better trade-off of utility versus privacy. So since I can't see you, I don't know if there are any questions there. Am I going too fast? Is there anybody who wants to ask a question at this point?
Shafi, I think we will take all the questions at the end to...
Okay, yeah. Save time. Okay, so I said trusted hardware. So I think people in this field at least know that there was Intel SGX, was a confidential computing hardware, and these days there's something by NVIDIA called H100 GPU, so it's a GPU, and again, a confidential computing hardware. What does that mean? That means that they sort of tell you, here's a box, and give me your encrypted data, and inside the box there's a key that will decrypt the data, do all the training and output. And then there's even another box which has a proof that the computation was done correctly inside of the box. So the promise is that there's very high performance here of confidential AI. You can, and they claim that you could do inference, fine-tuning, even training, and you can approach it in the cloud. The problem here is that you're really believing that this black box works as is. And historically, especially people have done a lot of scrutiny for the SGX, and now they should be doing it for the NVIDIA. There's been a lot of side channel attacks, which enable leakage of the secret keys. So there also could be bugs, and you, in some sense, need, although this is what they're trying to address here, to give you a proof that there aren't any bugs, but you must trust the companies to a very large extent these days. And there is some work in academia that took, like there's this work on called Notary. This is work by some people in MIT, where they took a very simple hardware device, not a general purpose trainer, it was a wallet, and they applied formal verification methods to it to show that this piece of hardware is in fact secure. But there's a lot of work in this paper, and the question is, of course, how to apply this at scale. That's an open research problem. All right, let's go on to the verification stage. So I moved from training to post-training, and I think that one of the most important things that one should do and press on machine learning pipeline is that it's not enough to train and then use, but there should be a verification stage. So what do I mean here? I mean the trainer might be adversarial, or there was data poisoning. We would like to verify properties of this model that we are handed. For what kind of properties? That it really is a good quality, that it's robust, which I'll define in a minute, that it used the right data, that obeys regulation. This is a billboard, for example, that you see on the way from Berkeley to Stanford, where this company says, we make AI work, don't just trust us, test us. So instead of using the word test, I would use the word verify. Now, of course, when we verify, we want to verify cheaply. We don't want to retrain. We might want to use fewer data samples, maybe lower quality data. We want to do this quickly with a little bit of memory. Sometimes they might not give me open access. So I'd like to be able to verify with black box access to the model. All right. So verification is an area that there's been a lot of cryptographic work. You know, there's from the 80s to today, there's been a lot of work on interactive proofs, zero knowledge proofs, non-interactive, like snarks, batch verification. This was the dream in a very early paper, I think, by, I think this was maybe 92, where the dream was there'll be a single processor, a single PC at the time, which will monitor the operation of a herd of supercomputers with powerful but unreliable software and hardware. Well, it's not that far from happening in the context of blockchains when you're verifying something like a smart contract very quickly. However, this situation is very, very far from what you need for machine learning. So the story is this: in the traditional world, there's in the cloud, say, some compute that's being done. You don't trust it, but you want to verify it, and you allow possibly interaction back and forth, possibly non-interactively. But what happens in our setting, the reason I claim that it's very different is because in the machine learning setting, we don't get an input, which is like, a document that has, and you want to verify it has been signed, like a document and a digital signature. You get samples from an input distribution. Your compute, like you send a model and you want to prove it's a good model, is usually you train this model in a randomized fashion, massively parallel. And the ground truth is not pre-specified. It's not that this contract has been signed and is good signature, but it's that the samples, the model you gave really fit the samples in some non-pre-specified way. So we need new definitions and techniques. So a lot of my work has been dedicated to that. For example, this is work together with Guy Rothblum and Jonathan Schaefer and Amir Yudayo, where we say, okay, you gave me a model, and I want to accept it if it's within additive error, say, from the best model there is. But I don't know what the best model there is, because it depends on the data. So we have some notion of what, in a minute I'll describe, and we want to do this efficiently. So we want it not to be too expensive to convince you this is the best model within additive error, and shouldn't be convinced if it's not the case, and you should do this faster than actually retraining yourself. So if we go to our recipe, see here was going to be a lot of use of the PowerPoint. If we go to our recipe, we want to verify that the hypothesis that we got is good. And let's just try to think that we want to compare it to all other hypotheses in a particular class. Like it might be a decision tree. We say among all these decision trees that exist, I give you one that's very close to the best. Or it might be a neural net of low depth, and I say this is the best two-layer neural net that can be done. So what's the challenge here? If indeed there is a decision tree that decides your ground truth, the H, perfectly, it's not a big problem, because you take the H, you as a verifier, you take a bunch of random samples and you test whether they work well. But when it's not realizable, so the best decision tree is not perfect, that's when this is a challenge. And what is a challenge? You're trying to verify that the loss of what you got is not too far from the optimal by an additive factor. But you don't know what the optimal is. So how are you going to verify it's close to the optimal with an additive error, as I require here in the good enough solution, if I don't even know what the optimal is? So we want to verify this inequality without computing what the optimal is. And it turns out that we can get positive results. So one example is about Fourier sparse, sorry. Let me put it up here. There's a theorem. So we show that whenever your function can be approximated by a Fourier sparse Boolean function, it is possible to do this. So to verify this equation, that the loss is not too far from the optimal by additive. And the verifier has a lot less power than the prover. So the prover needs membership queries, and that is the trainer. And the verifier doesn't, you can check that you've done this properly using only random samples. So there's a big difference here between training and verifying. Sorry, I removed this. I'm not going to show you how. It's going to skip a few slides. Let's talk about verifying robustness. I think that will be the last thing that we have time for. So what do I mean by that? What I mean is the following. Maybe I've outsourced my training. So I gave a trainer, and maybe what the trainer did is maybe put some backdoor in there, which will make it so that, so here's the situation. There's a client, gave the data to the trainer, and the trainer gave him back a machine learning model, and what I'm advocating here is that the client should try to verify that the trainer then gives him a good model, like a good quality model, like I said in the previous slides, but in addition to that, the model is robust. So what do I mean by robust? I want to be able to detect that when the model that I got back actually deviates from what it should do, when there's perturbations of x's in a distribution. So I wanted to train it on a particular distribution, gave me back a model. Let's say the model works good quality on the distribution, but maybe it's not robust. Maybe there's some perturbations on which all of a sudden the model will deviate. And I would like to be able to detect that. So who's the adversary here? It's the trainer. Maybe the trainer did something that is that will make my model non-robust. Why? Because the trainer may be a government that wants to have a backdoor, and he knows how to perturb inputs to get favorable outcomes. Maybe the following situation would come up. Here's the situation. Let's say that I'm a bank, and I give loans out. But I want now to be able to do this automatically. So I go to a company, I give it all my past history, which loans were approved, which loans were rejected, and so like green here, it was approved. A red here was rejected. So it's the whole profile of the loan and when I rejected, when I didn't reject, or when people faulted on a loan or didn't. The company, the AI company, figures it out, gives me back a model. Now this model is such that I could just automatically give it a loan, it will tell me accept or reject. But now what if the model trainer says, you know what, in the future I might want to get a loan. So I'm going to use some slight backdoor, a key, which will change the model ever so slightly in a way that you might not know, that you will not notice. But now, if there's a loan of my own that would have been rejected, I will change my loan description. I'll perturb some fields or something, because and how do I do it? Well, I know how to do it because I've kept a key. So now there's a newer, slightly different loan that will be approved. So how bad is this? Can it be done? What we show in a paper with a bunch of people that are Ol Zamir, Michael Kim, and Vinod Vaikunthanathan from MIT is how we can actually do this. For every neural net, we can put in a backdoor such that for every loan or for every X, the trainer who knows this key can find a close X, a perturbation, that will make the decision of the model reversed. Okay? So maybe here's the definition. There's the honest training model, and then there's the backdoor training, which essentially gives you, whether here you trained a black H, here's a red H, H prime. So when I trained it, I actually kept a backdoor. So the backdoor training gives back H prime and a backdoor, which was that key. And there is an activation routine that when I want to, I can apply an activation on X and the backdoor, and it will give me back an X prime, which is a perturbation of X, so that the decision of H prime on X prime is actually the opposite than on X. Now, if the bank could detect this very quickly, no problem. But what we prove cryptographically, on cryptographic assumption, that it's going to be undetectable. So the bank will not be able to tell whether it got an H or a backdoored H. Okay? So in this case, I'm actually proving not that I should trust technology, but that it's impossible to trust technology. So it's exactly, remember in the beginning I said sometimes you can use cryptography to trust, sometimes you can use cryptography to tell you when you should not trust. And this is like the latter. So what does it mean undetectable? So we have two sets of results. One is that what we're giving the bank is a black box model, okay? And the bank can now feed in X's and get back decisions, but it can't look in the guts inside. The way that it works is we show that if we take an original network and what we add to it a small portion, where what happens here is what this portion does is it looks at the input and tries to see whether there is the X is actually an X prime, where you took X and then you signed it and you made a portion of X prime is essentially the original X with this, where part of it is dedicated to a digital signature. And the network now checks whether there is a digital signature. So this is a verification routine, and if there is one, then it sort of changes the decision from the output, from a non-accept a loan to accept a loan. And since we have very, very strong digital signatures, if you cannot look inside this network and all you see are the inputs, X prime, and the outputs, or X and an output, you will not be able to come up with a new a new X that you could backdoor, or even tell that things have been backdoored. We also have a white box result, which is based on a essentially continuous LWE, which is another version of learning with errors, where we can plan a backdoor that even if I give you the network and the weights on it, you will not be able to tell there's a backdoor. This is kind of an interesting case. It doesn't apply to every neural net. It applies to very special neural nets called random Fourier feature neural nets, where you have one essentially nonlinear layer. And here, the interesting is that you don't have to modify when you train. Trainer is adversarial, right? He uses the data as is. He uses the training algorithm as is. All he changes is the randomness that he uses during the training. So all he needs to do is to tamper with the training randomness. And the reason cryptography comes in is essentially we'll take a pseudo-random distribution, which is indistinguishable from random under this assumption. And but it has in it the ability to kind of sway the decision from, let's say, don't accept a loan to accept a loan. So what's the takeaway from this? The takeaway from this is you have to beware of faulty randomness. The takeaway in general is that you never should trust the model that is given to you. What you should do is maybe try to post-process it in order to immunize it. You say, I don't know, I can't detect the trapdoor. Maybe it's there. But I'll do something to make my model robust. So we've tried. It's not so simple. So one obvious possibility is to do some gradient descent, stochastic gradient descent. That doesn't seem to work. We can maybe suggest not to just give the loan, but perturb the loan yourself in the bank to kind of fight against possible perturbations due to a backdoor. That works as long as you know what the magnitude of the backdoor is. If you don't, it doesn't work either. In some sense, the main message from this is it's going to be very hard to verify that there's no backdoor or verify robustness. And it's a very interesting question, how to get around this. So I think I'm going to pretty much stop here. The pipeline that I showed you, there are adversaries during development. There are adversaries in the verification stage. Sometimes we can deal with them, sometimes we cannot. There might be adversaries later after you think you've verified the model. And they're the kind of adversaries where the model was trained for one set of data, now there's a completely different set of data. Maybe just was naturally shifted, but maybe the worst case adversary again, given that we're thinking about a worst case adversary, chose a distribution which is going to fool your hypothesis. And this can be done when the adversary can look at black box, maybe white box. What can we do about it? So I have some work here with Adam and Yael Kalai and Omar Montasari, where we show some ability to deal even with the worst case adversary. And the idea there is that we change, we say, well, we can't really defend against a worst case adversary and still get a good model. So we'll get a model which is a good quality model, but sometimes it says, I don't know. I suspect that this is an adversarial input. And for some stages, for some settings, that might be the right thing to do. Say you're in a medical setting in the hospital, and your surgical system is going to tell you to do something severe, you would rather it said, I don't know, rather than give you an inaccurate advice. Similarly, with large language models, now often when you use, let's say, ChatGPT, often it will say, I'm a language model, I cannot answer. So in some sense, that's similar to I don't know. So that's all I'm going to say. I just want to end with saying that most of what I spoke about was prediction systems. But now generative models are all the kind of what we're paying attention to, and there are lots of challenges in language models. Verify the data source, distinguish fact from fiction, prevent bias, ensure that there's plurality of opinions, define rigorously what kind of regulation should be there, and methods to achieve them. I'm going to end here. Thank you very much. If there are any questions, I'll be very happy to answer them.
Thanks a lot, Shafi. Let me see what questions we have. Any questions from the audience? So I had a couple of questions. First, can you hear me, Shafi?
Yes, absolutely.
So you've mentioned two lines of research, but one is the backdoors where you are able to negative resistance.
Yes.
Before that, you had this proving that your model is output is performance good enough. Sometimes there it almost looks like you could have used the proving approach to defeat backdoor because it's backdoor not then original kind of model.
Oh, no. Because when I was in the part of the talk that I talked about proving the quality, that was with respect to a specific distribution. The backdoors are a perturbation of the original distribution.
So I see. So when you're proving that your solution is good, it's like only the data is from the correct distribution?
You're proving it with respect to a distribution. And the verifier has access to this distribution, say. So he has some random samples, and he's trying to figure out whether the model he received is as good as the best, but with respect to the specific distribution that he has samples for. If he wanted to do this with respect to the backdoor guy, you would need to figure out how you do the perturbations. And what we show is that that's impossible, because otherwise you would be able to detect there were backdoors. Yes, but by definition, backdooring is not with respect to the distribution that you have.
Let me, can you come over here to ask the question? But I think we need to, she needs to.
Hello, Shafi. This was a fantastic talk. I found your ideas around backdoors in the model quite interesting. And I was wondering if we can use some of those ideas for AI alignment. That is, maybe have an intentional kill switch built into the model, which is undetectable and maybe unremovable too. That is, given lemons, can we actually make lemonade here?
Yes, it's a very natural question. I think that Scott Aronson came after the paper, and because he was working watermarking, and he was trying to use this to put a watermark, for example. And alignment is also a very natural direction. Like, how do you kind of detect the intention? So the reason we did it for watermarking, right? Who's putting the backdoor? It's the trainer, right? And he wants to detect the watermarking case. He wants later to show that it was his output rather than somebody else's, and his backdoor enables him to do so. In the case of alignment, it's a little bit different, right? So we want to, you might be able to show that you cannot align, but that would be easy, right? Because that would be, you'd say, here's a way that I can trick you. But why would I want to trick myself? One is to think of the setup. But I completely agree with you, that this ability to have insight into the model that nobody else can have, so that later you'll be able to manipulate the model, might have a lemonade aspect to it. One is to think exactly what the setting is in alignment. But I agree with you. Alignment is the big question right now. Yeah, one more question, and then I think I gotta go. Sorry, because of. Right. Yeah. Yeah, that has to do with, it's a very good question. So for example, you could say explainability is that it matches the data, right? But that's not what you mean. You mean that there's really something that explains why it matches the data. And that is, I don't see that is as a cryptographic yeah, you might use the simulation type paradigm to define it, right? So the simulation paradigm definition is, this is the best there is. So, in some sense, for any explanation, for anything you could do with an explanation, you could do with what I'm giving you. So when we talk about an explanation, we could talk about why do we want an explanation, right? We want an explanation because we want to present maybe to a third party. Because maybe it helps in arbitration. So the way I would go about this is I would think, what is it that we want an explanation, and then come up with an alternative formulation of. Yeah. Right. So there is someone who is interrogating the explanation. And perhaps that's the right way to go. Yeah. Yes, thank you guys. And all right, thank you. Bye.
Thank you, Professor Manoj. So as we draw near towards the end of this insightful journey, would like to extend our heartfelt gratitude to each and every one of you for being a part of Trust Summit 2023. So now I would like to request Mr. Mukul Joshi, the Program Director of Trust Lab, to please join us on stage and deliver the vote of thanks. Thank you.
Thank you, Rima, and thank you everyone here. So as we bring the Trust Summit to close, I would like to extend my heartfelt gratitude to each and every one of you being part of this event. First and foremost, I would like to express our appreciation to our esteemed panelists, speakers, and moderators who have generously shared their expertise and wisdom with us today. A special thank you to our sponsors and supporters. Thank you to all our attendees. Thanks for your patience. We had a few disruptions and issues, but thanks for sticking by, and sincere apologies for those. Last but not least, I also want to thank our organizing committee, associated faculty, the DRF team for their tireless efforts in putting together this summit. Thanks to Professor Manoj and the executive committee for the inputs that they have given. So thanks to Shridhar and Sanjay for their guidance and helping us get connected with few of the speakers. So once again, thank you all for being part of Trust Summit. As we leave the summit, let us carry forward the knowledge, insights, and connections that we have gained here today. And we wish to see all of you again coming here next year, as well as multiple times, visit us, have the interaction, and let's see if there are any collaboration opportunities. Thank you. Thanks a lot.